Hello, welcome to my course. Here, we will embark on a journey to create incredible web applications using JavaScript and TypeScript. JavaScript is the world's most popular programming language, and TypeScript is a powerful superset of JavaScript that adds types to enhance code maintainability and scalability. Throughout this course, you'll gain a comprehensive understanding of JavaScript and TypeScript, starting from the basics and progressing to advanced functions. You will also learn how to use them for both front-end and back-end development, enabling you to create full-stack applications with ease. By the end of this course, you'll have a strong foundation in JavaScript and TypeScript, empowering you to explore any web technology you desire. This course is designed for anyone eager to learn JavaScript and TypeScript or improve their existing skills. Whether you're a beginner or an expert, there's something valuable here for everyone. However, please note that a basic understanding of HTML and CSS is a prerequisite, as we'll use them to build web application interfaces. Who am I? I'm a software developer with experience working on full-stack applications, and I'm enthusiastic about sharing my knowledge with you. Let's get started. Now let's unravel the curriculum. We'll start with the lexical structure, then arithmetic operators, then we'll dive into data types and unions in TypeScript, and then we'll learn assignment operators. Next, we'll learn about control statements, so that includes truthy and falsy values, logical operators, how to compile TypeScript to JavaScript, and the scoping and hoisting. Next, we'll learn about functions, alongside with the strict versus non-strict equality comparators. We'll also learn about IIFEs, which stand for immediately invoked function expressions. And then we'll learn about type aliases in TypeScript. Next, we'll learn about collections, so arrays, maps, sets, and tuples, alongside with iterables. Next, we'll learn about object-oriented programming, or commonly known as OOP. This includes classes, inheritance, polymorphism, and encapsulation. As for TypeScript, we'll learn about interfaces and generics, access modifiers, and type assertion. We will then learn about types of values, so generic constraints, with extents, index access, key of and type of, intersections, map types, and modifiers, all of these with TypeScript. Then we'll learn about the DOM, which stands for Document Object Model. Then we'll learn how to manipulate the DOM, then ES modules, then Vite.js, APIs, and JSON, which stands for JavaScript Object Notation. Next, we'll learn everything about making requests, so XML HTTP requests, promises with fetch, discriminated unions, async await, try catch, and finally local and session storage. Then we'll learn about the basics of backend development, so Express.js, which is a backend framework, HTTP methods and codes, runtime schemas with SOD, route and query parameters, and finally routers and middlewares. Now, something very important is that TypeScript is a very powerful language, and as I mentioned, once you learn TypeScript, you'll never want to touch JavaScript again. In fact, the vast majority of projects nowadays are ditching JavaScript in favor of TypeScript, making this the best time to learn TypeScript. For this reason, we'll work exclusively with TypeScript throughout the whole course. Having said this, I'll see you in the next video. Let us begin by installing Node. So for this, I'll open up my browser and search for Node.js. And I'll navigate to the official website, which is nodejs.org. Don't worry, you can find this link under the resources of this video. So what are we going to install here? We have the LTS version and we have the current version. Well, for this, we'll go with the LTS version. LTS is the abbreviation for long-term support, and this refers to the version of Node that received active support for a long period of time, and that a long period of time was 18 months. There they tested all of the bugs they found, security bugs, performance bugs, and so on, in order to be able to release this version that has great support and great stability. And what is this current one? It is the one that has the new features, the new implementations, and a lot of other things that the LTS does not have, because it is the most updated version. However, since it hasn't been tested, it hasn't been subjected to the same stability and security testing as this version, then that means that this version is for those who want to try the latest features of Node, but do not want to commit to a production environment when they are going to release an application with this version. This is just for playing around. In my case, I'm going to install this 18.16.1 version. But maybe when you're watching this, it could be a newer version. It doesn't matter. Just install the LTS version for you. Because although the version may be different, the idea behind Node and its fundamental architecture will not change too much. That is because updates and new versions will be more focused on improving and optimizing performance, fixing bugs, and adding new features. But there won't be a drastic change that will make the code written in previous versions incompatible with the newer versions. In my case, I already have it installed, so I won't do it again. But make sure to install it for your operating system. I believe for Windows and macOS it is basically the same. For Linux it could differ a bit, but there are a million guides out there showing you how to install it with Linux, especially if you prefer installing it with the terminal. Having said this, we can now move on to the next lecture. Now, you can use any editor you want, but I would recommend using Visual Studio Code, so we are all in the same page. For that, I'll search Visual Studio Code, and I'll open up the official website. Now, Visual Studio Code is an editor created by Microsoft, and pretty much everyone is using it, especially for developing with JavaScript, because in fact Visual Studio Code is written with JavaScript, and JavaScript being one of the most popular programming languages means that the support and plugins that Visual Studio Code offers is colossal. Anywho, download the installer with this button right here. In my case, since I'm in Windows, I get the Windows download. If you're using other operating systems, you should be able to find it here. Or well, you can expand this drop-down menu and you get the installer for macOS, Windows, and Linux. So once you have Visual Studio Code installed, I want you to open it so that we can configure our dev environment. So first and foremost, head over to the Extensions tab, and I'll show you which extensions to download. First of all, I would recommend using my theme, which is called Theme Night, which is this one right here. And this is the one that I'm using currently. Another plugin that is pivotal for you to install is Quokka, which is this one. This allows us for rapid JavaScript/TypeScript prototyping. So as we write our code, we get the result inline, which is absolutely great for the beginning. Next, I would recommend installing another one called Error Lens. And this extension simply improves highlighting of errors. As we can see, we get the errors right within the same line. You also need to install slint, which is a linter for JavaScript. You do not need to worry about what slint is right now, but make sure to have it installed. Next, install Prettier, so that we can format our code automatically, and we do not need to do this manually. And there are a couple other extensions that I recommend installing. This live server, so that we can have hot reload with our web applications. Material icons, so it's easier to navigate in the Explorer. This one called Pretty TypeScript Errors. I would also recommend installing Total TypeScript. And finally, install Thunder Client. Once you have all of these extensions installed, I want you to head over to this button cog. Click on it and then come here over to Settings. Once you have the settings open, come up here to the top right and click on Open Settings JSON. So this paper right here. And I want you to define this editor.default formatter option to be that of Prettier. so that it can automatically format your code. Add these two as well, so format on save and format on paste, and make sure to add this prettier configuration. Now you can find this configuration file under the resources of this lecture. So just go ahead, open the file and copy and paste it here. Once you have done so, you have successfully completed the dev environment. Now let's start with the lexical structure. When we write code, we create a set of instructions for the computer to follow to make it perform a specific task. However, in order for these instructions to be correctly understood by the computer, it is necessary to follow a precise and organized structure. This is where the lexical structure comes into play in programming languages. But what exactly is it? The lexical structure refers to how these instructions are written. It includes elements such as tokens, whitespace, comments, case sensitivity, and other elements important for the machine's interpretation of the code. Let's start with tokens. Tokens are the basic building blocks of code. They are the keywords, the operators, such as arithmetic ones. We have identifiers, literals, which would be the text, and punctuation symbols that make up the code. We also have a set of reserved keywords that have a special meaning within the language. These words cannot be used as variable or function names, but we will see this in practice. In addition to tokens, whitespace and comments are also important elements in the lexical structure. Whitespace includes any combination of space characters, tabs, or line breaks that are used to separate these tokens and make the code much easier to read. Comments, on the other hand, are text used to document the code. These have no effect on the behavior of the program. To write a single line comment, we use double forward slashes, and for a multi-line comment, we use a forward slash with an asterisk. Now let's look at the keywords. Keywords are specific words that have a special meaning and are used to give precise instructions to the computer. These keywords are reserved and cannot be used as variable or function names or any other type of identifier within the code. If we try to use a reserved keyword as a variable name, for example, the compiler or interpreter of our programming language will throw an error. In JavaScript, there are many keywords, and some of them are const, var, and let for declaring variables, if, else, switch, case, and default for conditionals, for, while, do, and break for loops, which means repeating a piece of code several times, and then function and return for declaring functions. And finally, let's talk about operators. Let's start with arithmetic operators, which are used to perform basic mathematical operations. The arithmetic operators used in JavaScript are the plus sign for addition, the minus sign for subtraction, the asterisk for multiplication, the forward slash for division, and the modulo operator used to obtain the remainder of a division between two values. Now, let's talk about assignment operators, which are used to assign a value to a variable in our program, similar to how we say in mathematics that x is equal to a value. These associate a value with an identifier. For instance, if we say x is equal to 5, then x is the identifier, and thus it will be associated with the value 5. Aside from the equal sign, which we know it assigns a value to an identifier, we also have the plus equal sign for adding a value to an existing variable, the asterisk equal sign, which does the same but for multiplication, the forward slash equal sign, which does the same but for division, and the minus equal sign for subtraction. Lastly, let's talk about comparison operators, which are used to compare two values or variables in our program. The most common comparison operators are the double equal sign, which is used to check if two values are equal, the triple equal sign, which is used to check if two values are equal and of the same data type, the not equal sign, which is used to check if two values are not equal, the not equal triple sign, which is used to check if two values are not equal and of the same data type, and the others to compare two numbers, such as greater than or less than, and so on. Let's start with declaring variables in JavaScript. Once you have Visual Studio Code open, come here to the top left-hand side, click File, and then click down here where it says Open Folder. The idea is for you to create a folder somewhere for this particular section. In my case, I created one under Documents called Source, then I created another one for Course, and then another one for the first section. Once you have it opened, come down here to this button where it says Select Folder, and once you have it opened, we can start programming. Now come here to the left-hand side where the Integrated Explorer lives, right-click here, click on New File, and then we can create our JavaScript file. Let's name it script.js and then hit enter. The script right here is the identifier, what we will use to identify the file. And then we specify the file type with .js, JS standing for JavaScript. Let's start with declaring a variable. For this, if you recall from what I said the last lecture, we can use 3 different reserved keywords. The first one being var. We can use var, then hit space, we can specify the identifier, so we can do x is equal to 5. Now if I hit Ctrl S, which is going to save the file, it should add a semicolon at the end of this file. This was done by Prettier, which is a tool, as I said in the first section, that automatically formats your document whenever you hit save. Now var stands for variable. Logically, that means that it can vary. In other words, it won't be stuck forever with this value right here. That means we can reassign this identifier to hold a new value. For this, we can come here to the second line and type x is equal to 10. Now if I hit save, it's going to add a new line at the end of the file. But as we can see on the first line, x holds the value of 10. But starting from line 2, x is going to hold the value of 10. So now let's quickly recap what we have done here so far. First, we use the reserved keyword var for variable, then we specify the identifier, and then we assign it a value. In this case, we do not need to specify this reserved keyword again, because this identifier already exists. The reserved keyword is merely creating this identifier for us to use. We can actually do x right here and just a semicolon, and this is simply going to point to this value right here. And finally, when we use the semicolon right here, we are specifying the end of line. That means we can break this line down by hitting enter here and here, and as you can see, it's still going to work. If I add a semicolon right here, it's going to give me an error. Now what happens if I delete the semicolon right here and hit save? If I do this, we can see that Prettier automatically formats this document and makes it pretty. Now JavaScript isn't a very strict language. That's why we can omit this semicolon right here. If you were to use other languages, perhaps Java, you may notice that it's not going to work as the compiler will throw an error. However, in the case of JavaScript, it's not necessary. There are some cases where it's better to use a semicolon, but in my case, I let Prettier do the job for me, so I don't have to worry about them. Now, var is the old school of declaring variables. There's actually a newer and better way of doing so, and that's using let. If I come here, type 2 forward slashes, I can write a comment. And if we recall, a comment is just documentation. It doesn't affect the execution of the program. And I can type let. Now, let wins over var. It's basically the same. You can redeclare a let variable, but just know that you should never use var. Always use let. Let's try it out. If I come here, double click, and then type let, we can see that the behavior is exactly the same. I can redeclare it however I want. I can point to this identifier, and I can initialize this variable, as we have done in the first line. But there's actually a third way of declaring variables, and that's using const. Now, const stands for constant, meaning that it cannot change. When we use let or var, think of variables that can vary, whose value can be redeclared in the future. Meanwhile, when we use const, we should think of constants, meaning that the moment we declare a variable using this reserved keyword, we can never ever change it after that line. That means if I come down here to line 4 and do const y is equal to 5 and do y is equal to 2, it's not going to work. Now, I'm in JavaScript, that means I can do whatever I want. But if I were to do this in TypeScript, it would throw an error, so bonus points to TypeScript. Now I want to show you one last thing, and that is the data types. If I come here to this variable, we can see number. And that is because, well, since we assigned a number to this identifier, we can see that our editor was able to successfully infer the data type. It can see that it is a number. But what if I change this to something that is not a number, for example, text? For this, I can use double quotes, type something, whatever I want, and if I come here, we can see that the data type inferred is of type string. And if we recall from the first video, a string is text. That means we get type safety up to a certain point, because we can always make sure that, well, X is of type string, hence whenever I use it, it will be a string. But that's not entirely true, at least not in JavaScript. If I come here where I reassign this variable right here and I hover over it once again, we can see that it is still of type string, when we all know that this is not a string, this is clearly a number. And this is completely valid, at least in JavaScript. If I were to copy this code, paste it in TypeScript, it would throw an error and tell me that I cannot assign a number to a string. That's one of the biggest problems with JavaScript. Now let's take a look at constants. If I hover over this one, we can see that the type is going to be 5. And that is, well, it knows that it will never change because it is a constant. So it can see that since it's 5, then it's still going to be 5 no matter what. That's why it doesn't say it's going to be of type number like it would do with a let or var declaration. Now we have found so far some major issues with JavaScript, and that is, well, first of all, the loosely typed system where we can assign this to a string and later reassign it to a number, which would be extremely confusing if we were to use this in production. And when we redeclare constants, if this is a constant, then how come we can do this? But actually we can see this error when we execute the code. Not this one, because, well, this is why TypeScript exists, but at least for these ones which are native to the language. To execute this file, what we can do is use an extension called Quokka. So we can head over to the extensions tab, search for Quokka, make sure you have installed it, and once you have done so, come back to the JavaScript file, hit Ctrl-Shift-P, and search for Quokka. Click on the command that says Start on Current File. And as you can see, once it's running, we can see that, well, first of all, X is value 10, because we're using this variable. That's why Quokka is showing us this 10 right here. And if we come over here to the 5th line, we can see that it says assignment to a constant variable. So we, at the very least, get some type of error when we do something that is not valid. But JavaScript is very error prone. That's why we're going to be using TypeScript for the entirety of the course. We have just scratched the surface here, but the amount of bugs you'll avoid using TypeScript is significant. Now, let's talk about some conventions when it comes to declaring variables. First of all, always declare all of your variables with const. It is common for beginners to use let everywhere, but let me show you why it might not be the best practice. First, let's delete all of this code. Let's say we want to declare a variable that holds a number. So let x equal to 5. Now, this would make sense if we were to redeclare it in the future. We might do x equals 10, but what if we never redeclare it? The issue is that the let keyword indicates a variable that can be redeclared, So whenever we encounter a variable declared with let, we may wonder if and when it will be redeclared, if at all. That's why I suggest declaring everything with const instead of let. By doing so, you're indicating to the reader and even to yourself that you will not be redeclaring this variable, alleviating any doubts about when it might be redeclared. This helps improve maintainability, clarity, and legibility, which are arguably one of the most important pieces of programming. Now, of course, if you ever feel the need to redeclare the variable, just change it from const to let. But remember, always declare everything with const so that you can be consistent. Now, let's dive into the different conventions when it comes to naming your variables. So we have the first one, camel case, then we have Pascal case, and then snake case. These ones are the most common ones. So camel case, we have multiple words like camel case concatenated together, so they are right beside each other without spaces. And the first letter of each word, except the first one, which would be camel in this case, is capitalized. For example, we might do const camel case equal to 5, or const number of students. So now we have 3 words capitalized except for the first one, and so on and so forth. We also have Pascal case, which is the exact same thing as camel case, except that the first one is capitalized. And then we have snake case, where everything is lowercase, but all of the words are separated by underscores. When it comes to programming in JavaScript and TypeScript, it's common to see these two, camel case and Pascal case. Though there are select cases where you might opt in for snake case, but we'll see them in the future. However, rule of thumb, stick to camel case. We'll see when we might use Pascal case. And lastly, let's talk about the different characters you can use for the identifiers. Now, the most obvious one might be spaces. You might be inclined to do const my name with a space, but this is not valid. Same with an equal sign. You cannot do my name is equal to something because this is a reserved letter, if you will. However, you can use underscores and dollar signs for your identifiers. You cannot use prefixes as variable names. For instance, if I do 3, my name, this is not valid. But if I add one at the end, or in the middle, or even after the first letter, this is valid. Now, super important, variable names have case sensitivity. That means if you declare a variable const y is equal to 5, const y capitalized is equal to 10, this is valid because these two are different. That's why it's case sensitivity. But what if you declare the same variable with the exact same identifier? If I do this, then this is not valid because this variable has already been declared. Hence, I cannot use this exact same identifier. We will see this in depth later on. Let us now start with primitive types and unions in TypeScript. So the first one is a boolean. A boolean is simply true or, so this bar is or, false. And it is merely the representation of a logical value. So how can we use this? Well, if I come here and type const true is equal to true, we can see that this is a reserved keyword. That means we cannot use it as an identifier for a variable. Let's try it out. So if I come down here, we can type const true is equal to true. It's going to throw an error, and it says true is not allowed as a variable declaration name. And the same applies for false. If I do const false, so case sensitivity, remember, is equal to false, this works. But if I come down here, const false is equal to false, then it is going to throw the exact same error. So now that we have seen in action how we cannot use reserved keywords, we can delete these two lines. Now let's take a look at numbers. So a number is a positive number, a negative number, or even a decimal number. Now in some other languages that might be more low level than JavaScript, they may have a data type that represents each of these. For example, in Java or C#, a decimal can be a double or a float. Now, the reason why JavaScript encapsulates all of these data types into a single data type, that is because JavaScript is a very high-level language. If you ever start to learn other languages, then it is going to be a great starting point, because you're now being introduced to these data types, which are incredibly important for a developer to know. So how can we type a number? Well, for that, we can come here and do const 5 is equal to 5, which is pretty straightforward. What about a negative? Well, it's simply going to be a minus sign as a prefix. What about a decimal? Well, it's going to be a point, so 0.3. But what about numbers that might be too big? We are all used, well, depending on your language and where you're from, to add separators to a number which doesn't affect its value, but makes it easier to read. For example, in English, it's common to see 500 or 5000 represented with 5, and 3 zeros. But how can we do this in JavaScript? Well, we cannot use commas, and we know that dots are for decimals. For this, we can use underscores. So const huge number is equal to, and we can do 5 underscore and 3 zeros. Now this does not change the value. In fact, this is the same as if we were to do 5000 without the underscore. Remember, this is for presentation purposes. The value is still going to be 5000. Now let's take a look at strings. So a string in JavaScript can be represented via a variety of characters. So we can use these double quotes, as we have seen before, or we can use single quotes, or we can use backticks. Now these two are the same, they have the exact same behavior. But this one, which uses backticks, well, it is still a string, but we can use something that is called a template string, but we'll see that later on. Let's try it out. So if I come down here, const double quotes is equal to, I type double quotes, and we can type any text we want. And as we can see, a string is simply text. What about this one? Well, single quotes, and we can do the exact same. But when should we use double quotes over single quotes or vice versa? Well, that is up to you. Since they have the exact same behavior, they both represent a string, it depends on your coding style. For me, I prefer double quotes, and the reason is because most languages use double quotes to represent a string, while some other languages, especially those that are lower level, they use these single quotes to represent a single character. In the case of JavaScript, we can see that these two are the same. However, just as with the semicolons, which are not required, I let Prettier do the job for me. So if I come here to settings, and then to this page right here, and scroll down to where you have your Prettier settings, you can see that I specified Prettier.single quote to false. This means that Prettier is not going to apply to any string the single quote rule, essentially using single instead of double quotes. So if I go back here to this file and hit Ctrl S to save the file, we can see that not only did it add the semicolons, it replaced the single quotes with double quotes. And this is very important for consistency. You'll never want to dive into a code base that has 1,000 ways of doing the exact same thing. It is very important to be consistent. But what about backticks? Well, if I come here, const backticks is equal to, and I type the same and hit Ctrl S, it is not going to change them. And the reason is because, well, they have some other special purpose. So that's why Prettier is not configured to change these backticks. Now we have undefined. So what is undefined? Well, it's simply a variable that has not been initialized. And what do I mean by initialized? Well, these are all variables that have been initialized, or in other words, that have been assigned a value. But how can we see a variable that hasn't been initialized? Well, we can simply do let initialized or non-initialized, and then simply a semicolon. If I hover over this variable, we can see that it is of type any. We'll see that later on. But it's important to know that right here, it is actually undefined. And this is useful because we may want to leave a variable as undefined, and then we can later define a value upon a certain condition. But this is also a reserved keyword. We can also use this. So this is going to be weird, but we can actually do is equal to undefined. Now, while this represents a value that is undefined, it really isn't recommended. For this, just leave it without assigning it to any value. Now that we have seen how undefined works, let's go to the final one, which is null. Now, null can cause a little bit of confusion when compared to undefined, but it is simply the absence of a value. With undefined, you're not defining any value, so it's undefined. Meanwhile, null is a variable that has been initialized but holds no value, hence absence of a value. Let's see this in action. I can do const y is equal to null. Now if I hover over y, we can see that the type is null. So in short, by using null, we're simply indicating that this variable right here holds no value or has been explicitly set to nothing. Now we'll see later on how we can use null and also why we would use undefined. But for now, understand that we have the null data type, the undefined data type, and of course, these three data types. These are the pillars of everything you'll be working on. Now, before diving into TypeScript, I want to show you one last thing. And that is, if I come here to the second line and hover over this variable, we can see that it is inferred as true. And that is true, because as we can see, we declared it with this value right here. But what if we used let over const in this case? Let's see. If I do let x is equal to true and hover over x, we can see that it is actually Boolean. And why is that? That's because, well, since we're using const, which is a constant, it knows that it will never change. Hence, our editor, which is actually using TypeScript under the hood, can infer that this variable right here will always be true. Meanwhile, since we declare this with let, it will try to find the type that we have assigned it to. In this case, since it is true, true pertains to Boolean. Hence, x should only be true or false. But as we know, if I come here and do x is equal to 5, it isn't going to yell at me, it's not going to throw any type of error. And that is because, well, we are in JavaScript. What happens if I copy this code to TypeScript? Let's try it out. Let's come here to the left explorer, right click, new file, and do script.ts. And let's come here, Ctrl A to select everything, Ctrl C to copy, and let's paste it here. And as we can see, we got an error. First of all, it says, definitions of the following identifiers conflict with those in another file. This is telling us that we cannot repeat these identifiers. For this, let's come here to this JavaScript and delete everything. And if we come back here, we can see that the error disappeared. And secondly, we can see that now TypeScript is enforcing this data type. It can infer that, well, since we defined it with true, it is going to be a Boolean. And hence, we cannot declare x to something that is not of Boolean type. And this is particularly why TypeScript is so powerful and everyone is switching over to TypeScript, because we can avoid these dumb mistakes. Now let's delete this line, and I'll show you how to explicitly declare the data types. Now this is a feature that exists solely on TypeScript, and that is, let's take this example. Let's say we want this variable to be undefined, and if a certain condition is true, then it should hold a number. How can we type this using TypeScript? Well, first of all, we can see that it is of type any, and any is something that exists in the world of TypeScript, which is basically what JavaScript relies on. This is essentially telling us that this variable can hold absolutely any value. Just as we did here, x is equal to 5 and it throws an error. If I come here and do non-initialized is equal to a number, this is valid. And then to a string, this is also valid. And the reason is because TypeScript won't type this variable right here as undefined, but rather rely on any, which shouldn't be the default behavior. Anywho, we can come here and do colon and write undefined. By doing this, we're explicitly telling TypeScript that this variable right here will be of type undefined. Now, where does this syntax come from? Well, if I come here and hover over any variable, we can see it here. Now, this is inferred automatically by the editor, which again uses TypeScript under the hood. That's why we get some sort of intelligence when it comes to data types. But now let's come back to this example and say we want this variable to be a number if certain condition is true. Now, I won't show yet how conditionals work, but let's imagine that this is wrapped into a condition that says if 10 is greater than 20, then this variable right here should hold this value. Now, of course, TypeScript is giving us an error, and we can simply delete this type annotation, and by doing so, we rely on any. But again, this is not recommended because why use TypeScript? JavaScript already uses any for everything. For that, we can use something that is called a union type. So I'll type it here, union type. And this means a variable that can be of multiple types. If I come here and do dot or column, number or undefined, this is going to be valid. As we can see, if I hover over this, we get number or undefined, which is the same character I was using for these comments right here. Now, this operator can be used multiple times. We can in fact specify that this variable right here can be a number or undefined or a string or even a boolean. For this, we can just chain them. And now we can assign it as long as the data type or value we're passing in is of these data types. So I can come here, do undefined, this is valid, a string, true or false. But what happens if I pass in null? So we can see this gives an error. Now that you have seen how union type works and all of these primitive data types, I want you to fix this by adding the null data type. Give it a try. The solution is simple. We can simply do or null. Remember, null is a data type just as undefined is one. Now let's try something. Let's copy all of this code and paste it to this JavaScript file. If we do so, we can notice something instantly, and that is, well, we get an error. Type annotations can only be used in TypeScript files. And this is something very important I want you to understand, and that is, TypeScript is built on top of JavaScript. So everything you can do in JavaScript, you can do in TypeScript. However, since TypeScript is a superset of JavaScript, and clearly the biggest difference is the type system. Now, before wrapping up this video, let's come back here to the TypeScript file and I'll show you how to use any. Now, any is escape from TypeScript. It is a way to get into JavaScript's world. Just like with the other type annotations, to use it, we can do let z of type any is equal to 5, then z is equal to true, then z is equal to a string. This is a feature that TypeScript has, however, it should never be used. It's bad practice and you should steer clear away from using any. Having said this, we can move on to the next lecture. I've prepared a few small challenges that I want you to take on. Although they might seem easy, the goal is to help you get started and familiarize yourself with the syntax. Let's start with the first one. Declare a variable with the type of string. Give it a try. This one's pretty simple. You can use either let, var, or const, but remember, do not use var. We could do let x is equal to an empty string. Now if I hover over this variable, we can see that it is of type string. But remember, if we were to use a const, the editor, which uses TypeScript under the hood, can narrow down this type for us because it knows it is a constant, a variable that will never change once declared. So the type is an empty string, and this is valid. But the idea for these challenges is to also get used to the syntax of TypeScript, not only JavaScript. So in this case, you could declare the type explicitly. Now what this is going to do is in a certain way overwrite the inferred type with the one that you just gave this variable. So as we can see, it is no longer an empty string. Now is this true? Not necessarily, because we have seen that the type is actually an empty string. So that's why when it comes to initializing variables, it is best to let TypeScript do the job and infer the types automatically. But for now, let's declare them explicitly, just to get used to how this type system works. Let's move on to the next one. Declare a variable that can either be a string or a number. So remember union types. Give it a try. This one's pretty basic. We can do const y is of type string or number. Remember, this represents an or is equal to, and we can either declare it with a number or with a string. So let's give it a try. As we can see, with a number, it works, and with a string as well. If we try to set it to something like null, it is going to throw an error. Now that we got this one out of the way, let's give it a try for the next one. Declare a variable that can either be a string or null. Again, we can simply do const z is of type string or null, and we can initialize it with null. And for the final one, declare an uninitialized variable with the type of string. Give it a try. So in this case, keep in mind that if we write let a and leave it as it is going to infer, or rather default to the any type. But this is not what we want. Although we can use a string, so a is equal to a string, we lose all type safety, because again, this is of type any. We want to make sure only a string can be passed to this variable. So we can explicitly declare the type. So we can come here and do of type string. However, this is not the solution. And the reason is because on line 11, it is actually undefined, not of type string. So we're lying to ourselves, even though we know it should only hold a string, it is undefined. So we should be using a union type, just to make sure our code is not error prone. So we can do string or undefined. And now this is a clear representation of what this type should hold. However, I want to point out something, and that is if I remove this line and remove this undefined, and let's say we were to use this variable, it is going to throw an error. It says variable a is used before assigned. Fortunately, we get some sort of assistance, but this is entirely up to you. You can either leave it as a string or as a union of string or undefined. In the future, we'll see what exactly this entails. Let us now take a look at the arithmetic operators. We can define two constants, x is equal to 5, const y is equal to 10, and then we can perform mathematical operations using these two constants. Let's try adding these two values. So for this, we can do const sum is equal to x plus y. But how can we see the result? Well, remember, we're using Quokka, so you can simply declare your variable, and as you can see, it is going to tell you its value in this particular line. Let us now try the other ones. So const difference is equal to x minus y, and then we can see the difference is going to be -5. Same for multiplication, so the product of these two is 50. Then division, and then we have the modulo, which is the remainder after division. As we can see, if we get the remainder, it's going to be 5. And finally, we have exponentiation. Now, you might be used to the caret for exponentiation, but in JavaScript, the caret represents a bitwise operator, which we'll not see in this course as it is not relevant. So let's try it out. Const power, and the result is a pretty big number. But what if we were to use the caret? So bitwise operator is equal to x caret y, and if we see the result, it's going to be 15. This is why it is important to remember that this represents exponentiation, this is a bitwise operator, And something very important about arithmetic operators is you cannot perform these operations on values that are not of type number. Now this might seem obvious, but in JavaScript you can actually perform these operations on values that are not of type number. But you will obviously get unwanted results. So let's try it out. What happens if I do const nan is equal to, so a string, and we want to add this empty string to a number. If I do this, we can see that it is going to be 5. Now, why is this? Well, it can see that this is actually represented as 0 because it is empty. So it coerces this value, and coercion in programming means turning one value of one data type to another data type. So for instance, if we were to write 5, this is actually going to coerce the number 5 to a string so that it can add them. What happens if we add other letters that are not numbers, for example, ASD? As you can see, it is going to concatenate these two. So it gets this string, converts these to a string, and then adds them together into a single string. But what if we were to multiply this string with this number, or maybe divide this string with this number? If we do this, we can see that we get not a number. And TypeScript throws an error and says the left-hand side of an arithmetic operation must be of type any, number, big int, or an enum type for it to work. Now again, this comes from TypeScript. If we were to copy this code, use it in JavaScript, it wouldn't throw an error. It would be completely valid. And the reason it is throwing this error is because the plus sign is actually used for concatenating strings, not only for adding two numerical values. So for instance, if I do this, ASD, as you can see, it just concatenated these two strings together. But when we use any of the other operators, which cannot concatenate two strings, or rather cannot be used for two strings, you'll get something that is called not a number. But what exactly is not a number? Let's see. If I do this again and hover over this variable, we can see that it is of type number. And not only that, but we can use it as a value. So I can do const z is equal to not a number. And again, if we hover over z, we can see that it is of type number. Not a number is simply a placeholder, a way to represent something that cannot be represented as a number, but it is still of type number. Now this can be quite confusing, but hopefully you'll never run into this issue by using TypeScript. Now the plus sign can be a little bit confusing because not only does it represent the sum of two numbers, but it can also be used for concatenating two strings. So this is why I avoid using the plus operator for concatenating two strings and always default to using template literals. Now, what are template literals? If you remember, I told you that we have three different ways to represent a string in JavaScript. The first one using double quotes, the other one using single quotes, and the other one is using the backticks. To use them, what we can do is come here and use the backticks, and then we can use a $sign with the brackets. And what this does is like escape from the string, and we can pass in any value that we want, and it will try to coerce it to a string. So we can do X, then another $sign, Y, then we can pass in an arbitrary value, so 125. And what this is going to do is again concatenate this to be a single string. So how can we see the result? Well, we can assign it to a variable and then use it like we have done here, but I'll show you another way, and that is logging or printing to the console. So how can we do that? Well, we can do console.log, then open parentheses and pass in this value. What this is going to do is show the results to the terminal or to the console. In our case, we're not using a console per se, we're not running the code. What we're doing is letting Quokka run it for us. And what it is doing is behind the scenes while taking what is being printed to the console. So in this case, it's like Quokka was printing every single value right here. It takes the result and then displays it to the editor. So in this case, we're doing it manually. And as we can see, we get 5 space 10 space 125. But how can we make sure this is actually of type string? Well, for that, we can copy this result. Const x is equal to this, and if we hover over x, we can see that it is of type string. Now we get an error, it says that we're already using x, so we can pass in L, for example. And if we do this, we can see that it is of type string. So this is an alternative to doing this. Console.log x plus y plus 125. Now this is going to be a number, so we have to convert this to a string. For that, we can simply pass in an empty string and then add the rest of these ones. But we get all of them concatenated right with each other and not with the separators. To add the separators, we'd have to do this and then another one. And by doing this, we get the exact same result. And finally, let's move on to the unary operators. So these ones are for performing arithmetic operations to numbers. So these two increment 1 unit to x, while these two subtract 1 unit, so decrement from x. So let's see them in action. Suppose you have a variable, so let a is equal to 10, and you wanted to add 1 to this 10. For that, you can do a is equal to a plus 1. However, there's a shortcut, and that is using the unary operator, so a plus plus. Now this achieves the exact same thing as this line. So let's comment this line with the shortcut, and then we can do console.log a, and as you can see, it is 11. But what is the difference between this one and this one? Well, by using the prefix, it is actually going to add first to the variable and then evaluate the variable. Meanwhile, this evaluates the variable first and then adds 1 to the variable. So let's see this in action. If I do a plus plus, so let me get rid of this one, it is going to be 10. But if I log it after this line, it is going to be 11. And why is that? Well, it evaluated the a first, logged it to the console, and then incremented a by 1. What if we do it the other way around? So plus plus a, well, adds 1 to a, then evaluates that number, hence we get 11. Same with subtraction, so we can do minus minus a, and as we can see, it is now 9. If we do it the other way around, it is going to yield 10 and then 9. So when should you use which? Well, that depends entirely on your use case. But don't worry, in the future, we'll see how we can use this. Let us now take a look at the different ways to coerce a value to a number. So the first one, which is the weirdest one, is by using the plus sign. So suppose you have str, which is a string, we have 5, and we wanted to convert this to a number. To do that, we could do const number plus 5. By setting the plus sign as a prefix to a string, it is going to coerce the string to a number. So if we print this, console.log number, we can see that it is 5. And if I hover over number, it is of type number. What happens if it's ASD? Then it gives not a number. However, this is not the most intuitive way to coerce to a number. So that's why JavaScript has different methods, which we'll see what it is later on, to make it more explicit and clear. The first one is using parseInt, which is something that lives globally that you can use as you please. So you can do parseInt, or I'll comment this, and I'll copy this line and change this to parseInt. And as the name suggests, it is going to parse this string to an integer. So that's why it yields 5, which is actually not a number. What happens if we prefix it with letters? As we can see, now it is not a number. In its inner implementation, it is checking and trying to find a number. If we do 3 5s, then we get 555. But again, this is for integers, so if I use a decimal, we still get its integer. But what about floats or doubles, which if you recall, a float or a double is simply a number that holds a decimal. For that, we can use const number, so I'll comment this line out, is equal to parse float, and we can pass in this same value. And as you can see, it is going to coerce it with the decimal. But there's actually one more way to do this, and that is using the number constructor. Now we'll see what are constructors in the future, but for now just know that it gives you back a number. So we can do, comment this line, const number is equal to number, capitalized, and then we can pass in a string. And as we can see, it gives us the number. Strings aren't the only values that can be coerced to a number. You can actually coerce booleans to a number. Let's see what happens if I pass in true. It gives 1. What about false? It gives 0. And that is because false is an alias for 0. 0 is considered a falsy value. We'll see what this means later on, but for now understand that false is equal to 0 and true is equal to 1 in a sense. But when should we use which? Well, if you want only integers without decimals, of course, then use parseInt. If you want decimals, you can use either parseFloat or number. The thing with parseFloat is that it attempts to extract numbers from the beginning of a string. For example, as we have seen, if I do this and remove this line, we get not a number. But what about at the end of the string? It still returns 555.25, but the number constructor will return not a number either way. Let's see. And I comment this line, and I pass in ASD, we get not a number. In short, it depends entirely on your specific use case. Let us now take a look at infinity. So what is infinity? Well, you guessed it right. It's when representing a number that is too big. Similar to not a number, it is a global property, meaning that you can access it anywhere you want. So we can print console.log infinity, and as we can see, we get infinity back. But what is the data type for infinity? Well, if we do infinity is equal to infinity and hover over this variable, we can see that it is of type number. We also have negative infinity, so we just prefix it with a minus sign. And while it's not too important, again, we get infinity when we deal with numbers that are very big. So if I do, you can see that we get infinity. Generally, you will not encounter infinity unless, of course, you're doing arithmetic operations with huge numbers. This is something that you will not have to think about. I'll explain it regardless in case you ever encounter infinity, so you can understand its meaning. It's important to remember that in the end, infinity is still a number. That means you can perform arithmetic operations on it. Now, will you get the desired results, or were you expecting something unique? Not at all. As you can see, if we divide 1 by 0, we get infinity. Infinity plus 1, infinity, and 10 divided by infinity is still 0. Let's now take a look at compound assignment operators. So if we quickly recap, we have the assignment operator to give a value to an identifier. For instance, const x is equal to 5. We're binding this value right here to this identifier, which we can reference later on. But what if we want to modify this value and assign it the result of an arithmetic operation? For that, we need to change this const to a let so that we can reassign it. If I told you to add to x 5, you would do x is equal to x plus 5. Now x holds 10. If I log this to the console, we can see 10. But there is a shorter way to achieve this, and that is using the compound assignment operator. So you can do x plus equal 5. And as you can see, we achieve the same. We just specify which operator we want to use with the assignment, and this is going to automatically take this value and add it to x and assign this new value to x, which is pretty straightforward. And you can do this with pretty much any arithmetic operator. So x times 10, and as you can see, we get 100. Or we can divide x divided by 10, and we get 10 back. Same with exponentiation. So x to the power of 10, and we get this huge number. They are incredibly useful, and it's best to avoid using the syntax right here. Instead, always default to compound assignment operators. But before moving on to the next lecture, let's take a look about more arithmetic operations here. So what if we wanted to add not only 10, but the result of a specific operation here? Perhaps 5 plus 10 times 20. If we do this, it's going to solve this first, then this one, and finally assign the result of this to x. In the upcoming lecture, I'll introduce a brief challenge to help us review all the concepts we've covered thus far. Now I've got a small challenge for you. Let's try and solve this. First of all, increment a number by 1 with as many different ways as you can. Try it out. For this, we can declare a variable 1 is equal to 1, and we can use the unary operator the other one. We can also assign it to 1 plus 1. And finally, we can use the compound operator, plus equals 1. Now we can log this to the console. Let's move on to the second one. Decrement a number by 1 with as many different ways as you can. Give it a try. For this, it's the exact same, but with negative. So 2 is equal to 1, then 2 minus minus, then as a prefix, then 2 is equal to 2 minus 1, and the compound operator. And as we can see, we get negative 3. Now let's move on to this one. Convert the number 20, so type of number to a string with as many different ways as you can. Try it out. There are 3 different ways to solve this. There's probably 1 or 2 more, though the most basic ones could be const result1 is equal to 20 plus an empty string. Now if I hover over this, we get a string. Next, we have template literals. So const result2 backticks, and then we escape from here. And if you recall correctly, this is going to coerce it to a string. And finally, we have the equivalent of the number constructor, but with a string. I haven't shown you this one yet, but if you researched it, you should have stumbled across it. For that, we can do const result3 is equal to string capitalized, and we pass in 20. And if I hover over it, we can see it is of type string. Now let's move on to the fourth one. Convert 20.5 to a number with as many different ways as you can. Give it a try. This one's pretty straightforward. We can do const result1, and I'll postfix it with 4 is equal to parse in 20.5. Now this gives us a number, obviously. The other one is const result2 4 plus 20.5. And if I hover over it, we can see it is of type number. And finally, we have the number constructor, similar to the string constructor. Const result3 equal to number 20.5. And finally, we have the fifth one. Multiply a number by a string with a value of 20. So the string is 20 using the compound operator. Try it out. This one might be a little challenging. We can do let number is equal to 10. And then we can do number times equal to parseInt 20. And why? Because this gives us a number. So that's why we can treat it as any other number. Or we can also do number times equal plus 20. And if we log this number, as we can see, it logs 4000. Now that we have completed this challenge, we can move on to the next lecture. Welcome back to this section where we'll be going over control statements. Let's start with if statements and conditional operators. Imagine you're standing at a fork in the road. You can choose to either go left or right based on certain conditions. Maybe you want to go grocery shopping, or perhaps you want to go for a walk in the park. Now the decision could be based on a prompt to the user, so we ask the user where they want to go. For this, we can use booleans, where we could define a variable named grocery shopping that can either be true or false. If it's true, then direct the user to the grocery store. Otherwise, lead them to the park. So in a sense, the park can be considered a fallback, as if the condition is false, it will lead to the park no matter what. So it's a 2-option choice. To represent this in code, what we can do is write const grocery shopping is equal to true. And then we can mirror this road right here, but in code. So we can do if grocery shopping, then we can print to the console, I need to buy groceries. What about the right hand side for the park? Well, for this, we can use the else. And what this is doing is defining a fallback. So if this is not true, then it will default to this block of code right here. And inside of this, we can write, I need to go for a walk. Now make sure to run Quokka, so Ctrl-Shift-P, and start on current file. And as we can see, we get I need to buy groceries. To know which lines took effect and which not, we have these squares. These squares come from Quokka, and they represent which lines were executed. If the line is in green, that means this line was executed. If the line is blank, that means it wasn't executed, but it can be executed. So if we change this to be false, then again this will resort to this fallback, and hence result in this line not being executed, and this block of code in green. Let us see how this works exactly. For this we have conditional operators. So we have the double equal, which represents equal to. So suppose you want to say if x is equal to y, you can use this one. We also have the not equal to compare two values and find out if they are not equal to each other. So in essence, this returns true if they are not equal, or false otherwise, and same with this one, but vice versa. We then have greater than, less than, greater than or equal to, and less than or equal to. These ones are obviously for numerical comparisons. So you might be wondering how come this works. We're not using a conditional operator. So how come does this condition take effect? Well, it's because this is a shorthand way of using the conditional operator. This is the same as if we were doing if grocery shopping is equal to true. Now TypeScript throws an error and says this comparison appears to be unintentional because the types false and true have no overlap. And that is because we're using a constant, so it knows that it will always be false. In our case, if we switch this to a let, then, if we hover over this, we can see that it is of type boolean, but it is still throwing the error. And again, it can infer or it knows that this is going to be false at the time being, even if you try overriding, which makes no sense because it is already inferred as a boolean, it won't change the effect. But for the simplicity of this example, let's just keep it explicitly defined, because usually this would come from an input from a user, so you cannot know ahead of time whether the user will input true or false. Anyway, let's take a look at these different conditional operators. So let's start with this one, equal to. So if we print console.log, null is equal to null, this is going to be true. What about undefined? Is undefined equal to undefined? True. Let's check with numbers. 4 equal to 4, this gives true. What if we change this? Then this is going to be false. And what about strings? Can we compare them? Console.log, empty string is equal to an empty string. This is going to yield true. What if it has content? So ASD and ASD, this is still going to be true. So as we can see, this one is pretty self-explanatory. Now let's take a look at the not equal to. So console.log, is null different than null? This is going to be false, obviously. What about with undefined? We get false. But let's check this. Console.log, is null equal to undefined? This gives true. Interesting. As we can see, JavaScript treats null the same as undefined. But this is not the only weird behavior. We have more. What about is 0 equals to false? Okay, this gives true as we can see. What about is an empty string equal to 0? We still get true. And this seems pretty inconsistent. Doesn't make much sense as to why we would get this when we are evidently comparing two values whose data types are completely different. And that is because these two, so this equal to and this not equal to, compares two values even if they are of different data types. The behavior we would expect is an empty string equal to a number. Well, this comparison shouldn't even take place because it makes no sense to compare two values that are of different data types. You should at the very least convert this string or try to parse it to a number and then compare the result of that with a number. Same as this one, how come null is different than undefined false? So for that, JavaScript introduced a new conditional operator, and that is the strict equality comparator. So triple equal, this is the strict equal to, and then we have the strict not equal to. And what this does is simply check if the two values are of the same data type. If the data types are different, they will result in false output. This is because a value belonging to one data type can never be equal to a value belonging to a different data type. So let's see, what if we change this to a strict equal to? As we can see, if I hover over this, we now get false. What about null compared to undefined? This gives true. They are indeed different. So now that we have understood how this works, you should only use the strict conditional operators. Now these ones don't apply for these ones because it makes sense. Here we're comparing if two values are equal. Meanwhile, these are for numerical comparisons. In a nutshell, what you should do is forget about these two operators. You should never use them under any circumstances. Instead, it is always preferable to rely on the strict operators as the default choice. So let's see this more in practice. For example, what if you wanted the user to input, or perhaps you're calculating the age of the user and you want to know if they are an adult or not? For that, you could do const age is equal to, let's say it's 18, and you could declare another variable, which is going to be a boolean, is old enough. And here you're simply using the conditional operator to compare this age and check if it's greater than or equal to 18. Now this will give a boolean, as we can see, true or false. So we can use this to then check and perform some code based on this boolean. So if is old enough, and here we declare the block of code, remember. We'll see what this means later on, but for now understand that whatever is within these brackets will only be considered, or in other words executed, if this condition results in true. So we can do console.log true, and then we can maybe declare a variable const name, and perhaps it's going to be John, and then we can print this right here. And in the case that person is not old enough, we could do else, and here we can say, okay, this is going to be false, and then we can print to the console again, you're not old enough to drive. Now that we have seen this in action, next lecture it's going to be a small challenge, so you get used to this syntax. I have prepared a small challenge that I want you to try and solve. So let's start with the first one. If a number is less than 5, print the number is way too small. If the number is greater than 5, print the number is way too big. And finally, if the number is equal to 5, then print the number is 5. Give it a try. What we can do is define a variable, so const number is equal to 5, and then check. So if number is less than 5, we log to the console, the number is way too small. Then we can use an else. So if it's not less than 5, we can check if number is greater than 5, print to the console, the number is way too big, else the number is 5. So as we can see here, we have nested if statements, and we have defined it within this block. So this will be considered only if this condition is false. And if we execute Quokka on this file, so start on current file, we can see that we get the number is 5. So to recap, it checks if the number is less than 5, well, this is going to be false, then resort to this else. And then it checks if the number is greater than 5, which is not the case, else print to the console the number is 5. But this is not very clear. Sure, we have this if statement and then we can see an else, but we can simplify this further by nesting if statements within a single one. Now what do I mean by this? Well, I'll comment all of this, and we can do, well, I'll copy this line right here, paste it here, and then we can use else if. And then we can add the rest of the logic. Now this is very straightforward. It is reading it from top to bottom. So it comes here, checks this condition, then this one, and finally resorts to this else. If you specify one, of course, you can omit this entirely. You can delete it and it's going to work just fine. And you can have as many else if as you want, as long as, well, you have the base if statement. So you can do else if, the number is equal to 5, then else if, and so on and so on. Obviously, if we do this, this will never be executed. And the reason is, let me change this to 6, which would be the last condition. We can see that it executed this piece of code right here. And the reason is, well, it comes here, checks number is greater than 5, so this is true, execute this line, and bail out of these conditionals. So you have to be careful and make sure that all cases are reachable. You should never define an if condition if it's unreachable. Let us now move on to the second one. Write a program that checks if a number is even or odd. If the number is even, print the number is even, otherwise print the number is odd. Now a hint, use the modulus operator to check if a number is even or odd. The modulus operator returns the remainder of a division operation. For example, 5 modulus 2 returns 1 because 2 goes into 5 2 times and leaves 1 left over. So 2 times 2 equals 4 minus 5 is going to give us this 1. And same with 6 modulus 2 returns 0 because 2 goes into 6 3 times and leaves 0 left over. Give it a try. Let us now try and solve it. So let's write const to test is equal to 2. And then if to test modulus 2 is equal to 0, so if it is even, we can log this to the console, otherwise log the number is odd. Now let's try changing this number to 3, this number is odd, what about 5, odd, and 4, even. We can now move on to the next lecture. Now, something important to consider is that JavaScript itself is a strange language. And it makes sense because it was created in a very short time without much thought. So obviously it's going to have things that maybe weren't the best, and it has many strange peculiarities and inconsistencies, especially when dealing with values or control statements. The thing is, certain values are considered true while others are false, which doesn't make much sense, right? The only values that should be considered true or false logically are true or false, because those are booleans. However, in JavaScript, there is a notion of falsy and truthy values, as we have already seen. Now let's start with falsy values. So we have false, obviously, we have 0, we have an empty string, we have null, undefined, and not a number. And for truthy values, well, true and basically everything else that does not fall into these values right here. So if we try it out and do if 0, then this will never be executed. So let's do truthy. What about not a number? Well, the same. Falsy, undefined, it's going to be false. Null, false. But if we say 1 or 3 or 10 or perhaps the multiplication of these two numbers, this is going to be considered truthy. But there is something very important to consider when it comes to checking the validity of different values. You might see, and this is common practice, where you get name input. Suppose this input comes from a form in an HTML document, or perhaps this is a backend service which receives data and it needs to check if the name input is valid. So if it's different than these empty strings. Now the common approach would be to do if name input is different from an empty string, then do something. Or maybe we can throw an error and say console.log name is invalid. But people abuse the system of falsy and truthy values, and what they do instead is remove this comparison and leave it as such. Now the result is the same. Remember, an empty string is false. However, personally, I advise against this as I consider this to be bad practice, and it's best to always be as explicit as possible. I will always advise to change this type of logic to use a comparator instead. And as we can see, this is clearer. We now know exactly what it is looking for. So as long as you follow the common practice of always using these comparators, especially the strict equality comparators, You should never have to think about falsy and truthy values, aside from, obviously, true and false booleans. Now, before wrapping up this lecture, I wanted to show you something about the not operator. So we have seen that we can use the not operator in conjunction with the equality operator, and that is, well, to check if a value is different from another value. But we can also use it to negate an expression. So suppose you wanted to check first if this is invalid, rather than checking if it's valid and then resorting to this else for the case where it is not valid. For this, you might also see this kind of logic. So if not name input, it is going to get the Boolean representation of this name input. Now, since this is a falsy value and we use the not operator, it is going to invert the condition in such case that this will now check if name input is invalid. Otherwise, well, if it's valid, we can resort to this else. Now again, do not do this if it's not of type Boolean. If you want to do this, you can change this to be if name input is equal to an empty string. And now you're checking if it's essentially invalid. But what if this was a Boolean, or perhaps const is name valid? And then we can use this here, so is name valid. And well, since this is a Boolean, we should also be able to use the not operator to invert the condition, or rather the value. So in this case, since it is going to be false, then this will result in true, and hence print this line right here. But anyway, we'll see this in practice later on. Let us now take a look at the logical operators. So for this, we have the and or operators. So we use two ampersands for and we use two vertical bars for or. Now these are used to combine two or more conditions within a single if statement. So suppose we have const age is equal to 25, const income is equal to 50,000, and we wanted to execute a block of code if and only if age was greater than 18 and income was greater than 30,000. One approach could be if age is greater than or equal to 18, then execute this block of code, but then we need to consider the income. So if income is greater than or equal to 30,000, and we can print to the console you're eligible for a loan. But again, this makes it quite hard to follow. And we might also make the mistake of adding some part of the logic outside of this block right here. For that, we can use these two conditions, which must be true, with the and operator. So I'll comment this out, and I'll do if age is greater than or equal to 18 and the income is greater than or equal to 30,000. And now this is the exact same, but simplified. Let's test it. So what if we changed age to be less than 18? So 17, it won't execute. What about income? If I change this to 10,000, it won't work either. So remember, the two conditions must be true. Now what about the or operator? Now this one's different, where at least one of the conditions that you specify must be true. With the and, all of them must be true. So the left-hand side needs to be true and the right-hand side needs to be true for this block of code to be executed. Meanwhile, the or, so if we changed this to be an or, if either age is greater than or equal to 18, or if income is greater than or equal to 30,000, this block of code will be executed, as we can see. Let's give it a try with another example. So suppose you have const score is equal to 75, then attendance is equal to 90, and then we want to pass the course only if score is greater than or equal to 80, or if attendance is greater than or equal to 95. For that, we can do if score is greater than or equal to 80, or attendance is greater than or equal to 95, then print to the console, you passed the course. Otherwise, we can print to the console, you failed the course. As we can see, only one of the conditions need to be true. But just as with arithmetic operations, we can use parentheses to group multiple conditions and control the order of evaluation. For example, suppose we have 3 variables, so x is equal to 10, then y is equal to 20, and then z is equal to 30. And then we can group these conditions, so we can check if x is greater than y, but x must be greater than z, or, so this must be true at the very least, or if this one, so y is greater than x, and x is greater than z, we can print to the console, either x or y is the largest number. Otherwise, we can print to the console, neither x nor y is the largest number. So to recap what this is doing, well, it checks this condition. Is this true or false? If it's true, then it checks this one. Is this true? And if these two are true, then this condition right here will be evaluated as true. And with that, it doesn't need to check this right here because it can see that it's an OR operation, which means that one of them must be true for this to pass. In the case that this results in false, then it will check the right-hand side. And again, this must be true and this must be true for this condition to pass and execute this block of code. So let's try it out. Let's modify this x to 100. And if we do this, this block of code will be executed. And why is that? Well, because x, in this case, is greater than y, and it is greater than z. So it just like bails out of this condition since this is true and goes right away to execute this code. So now that we understand these logical operators, we can move on to the next lecture. I created 2 small challenges that I want you to try and solve. So let's start with the first one. Write an if statement that checks if a number is divisible by both 3 and 5. Use the modulo operator to get the remainder of a division. For example, 15 modulo 3 is equal to 0 means 15 is divisible by 3. If the condition is true, print pass. If the condition is false, then print fail. Give it a try. Okay, the solution for this is pretty straightforward. We can define a constant, number is equal to 15, and then we can check if number is divisible by 3 and number is divisible by 5, then we can log to the console pass. Else, we log to the console fail. As we can see, well, 15 is divisible by these two, so it passes. But what about something like 13? Fail. What about 4? Fail. And what about 3? Or even 5? As you can see, the solution works. We can now move on to the second challenge. Write an if statement that checks if a string is equal to yes or no, or if it is equal to maybe or perhaps. If the condition is true, print pass. If the condition is false, print fail. Give it a try. Let us now go over the solution. So for this, we can define a string is equal to maybe, and then we can check if the string is equal to yes, or if the string is equal to no, or if the string is equal to maybe, or if the string is equal to perhaps. And then we can print this to the console, so log pass, otherwise log fail. Now remember, this is giving me an error because the TypeScript service that is checking our code can see that this string was defined as maybe, and that this line, it hasn't been modified. So it can infer that it will always be maybe. So we know that we shouldn't compare a value to this variable right here because, well, after all, it is constant. So this doesn't make any sense. But for the purpose of the example, let's assume this works. And as we can see, we get a pass in the console. But what about something else? Perhaps an empty string, we get fail. Now that we have solved this challenge, we can move on to the next lecture. Let us now take a look at how to compile TypeScript to JavaScript. So for this, open your terminal, so new terminal, and inside of here, type npm install -d and then TypeScript and hit enter. Once it's done, you'll notice this new directory called node modules, this package log.json and this package.json. The package.json contains metadata about your project. As we can see, we installed TypeScript using npm. npm stands for Node Package Manager, and as the name suggests, it manages your packages, or in other words, your dependencies for your project. By specifying this -d, we're telling Node Package Manager to install TypeScript as a dev dependency, which means that it will only be used for development. But once we build our application to production, TypeScript won't exist. And that makes sense because TypeScript is compiled to JavaScript. So what is actually being run by either your browser or your computer is a JavaScript file. It cannot run or execute TypeScript code. The Node Modules folder contains all of the modules that your project depends on. In our case, we only have TypeScript. So as we can see, this is all of the native code that is bundled and downloaded to our project. So now that we understand what these files mean, let us now initialize our TypeScript configuration. So for this, type npx and then tsc --init to initialize the TypeScript config file. And as you can see, it is also of type JSON. Now we'll see what is JSON later on, but for now, understand that it is a file where you can usually specify certain configuration for your packages. In our case, this tsconfig.json contains all of the configuration for TypeScript, where we can specify what version of JavaScript we want to compile to. So if we scroll down, we can see that we have target, which says set the JavaScript language version for emitted JavaScript and include compatible library declarations. So by using ES 2016, we're specifying TypeScript to compile our TypeScript files to this specific version of JavaScript. And if we scroll down further, we have modules, which we'll see what that means later on. And we also have root directory, which, as it says here, specify the root folder within your source files. So in other words, we must specify where our TypeScript files live. But how can we actually compile TypeScript to JavaScript? Well, for that, delete the JavaScript file, so right-click, and then delete permanently. And once you have done so, you can come down here and type npx tsc, which is the TypeScript compiler, and then write the name of the file, of the TypeScript file that you want to compile. In our case, it is script.ts. And if we hit enter, as we can see, it generated our JavaScript file. So let's come back here to our TypeScript and write some TypeScript. So const number of type number or string or undefined, and let's say this is going to be 5 and some conditions. So if number is different from undefined, then log to the console something. Now if I hit save, come back here to my terminal and execute the exact same command, and come back here to my JavaScript file, we can see that it compiled this code to JavaScript. So we lost all of the type annotations, so number or string or undefined, they are not here anymore. And it also changed this const to be var. Now the reason it uses var instead of const is because there's more compatibility with var. Certain browsers or certain environments do not support certain versions of JavaScript. So we also take advantage of the compiler and compile to a JavaScript version that most browsers and most environments support. But how can we now execute this JavaScript file? Well, for that, we installed Node.js. And if we recall, it is a runtime environment that allows you to run JavaScript code outside of the browser. So initially, JavaScript was created for the browser to add interactivity to websites. But then some developers wanted to bring their JavaScript code to the backend or to run scripts. so that they could share the exact same language for both their front-end applications and their back-end applications. And from that, Node.js was created. So we can come down here to the terminal and type node script.js. And if we hit enter, we can see in the terminal something, just as we printed here. And this is actually what Quokka is doing under the hood. It is compiling our TypeScript code to JavaScript, then executes the file and saves the output. And then that exact output is shown to us within the editor itself. But in our case, since we're executing the JavaScript code, it will show the output in the terminal. But what about compiling TypeScript to JavaScript? That means every time we make a change, we need to type the command, so tsc, and then come here to the JavaScript and then execute it. Well, for that, we can watch the TypeScript changes. So it automatically compiles its corresponding file to JavaScript once we make a change to this file. And for that, what we can do is come here to the terminal and type npx tsc. And instead of specifying the file name, we can omit that and simply type --watch. Now, by not specifying the file name, it will compile all TypeScript files that it finds. So if I come back here and let me change something to X and then save this file, execute this command and come back here to the JavaScript file, we can see the output is now X. So having that in mind, we can do npx tsc --watch. And then it started a process to watch for our file changes in our TypeScript files. And let's see if it works. So if I change this to 10, hit save, come back here to our JavaScript, we can see the change reflected. So now that we have learned how to compile TypeScript to JavaScript, we can move on to the next lecture. Let us now take a look at while loops. So what are while loops? Well, they are simply a way to run some code repeatedly as long as a condition is true. You can use a while loop when you don't know in advance how many times you need to repeat code, or when you want to keep looping, in other words, repeating a block of code until something changes. For example, you can print the numbers from 1 to 10. To create a while loop, you can use the keyword while. So we specify while, then parentheses, and within this parentheses, you specify the condition, same as an if statement. So we have if, condition, and then the block of code that we want to execute when this is true. So the idea is the same, but instead of executing this block of code once, a while loop will repeat the execution of this block of code. We can do let number is equal to 1, and then while number is less than or equal to 10, we can print to the console number, and let's add 1 to this number. Now remember, this is going to print the number, then add 1 to the number. And if I save this, come back to my JavaScript, we can see that it compiled the code successfully. And then to run it, we can open the terminal, create a new one here, and then we can write node script.js. And if we do this, as you can see, this printed the numbers from 1 up to 10. So let us recap quickly how this works. The loop starts by checking if number is less than or equal to 10. If it is going to log this number to the console. Otherwise, it will stop the execution of this block of code and move on to the next line. And that is something very important to understand. Code is executed from top to bottom. So it starts from this line and starts moving downwards. So then declares this variable, then enters this while loop, and once it's done, it moves on to the next line. And we can test it. So if we log finished, save this, come back to the JavaScript, we can see the result here, open the terminal once again, and then we can execute the same command. As we can see, it printed from 1 to 10 and then printed finished. So as we can see, JavaScript is synchronous in the sense that every line must be executed for the next one to be executed. And we can actually control the flow of execution using two special keywords. So the first one is continue and the second one is break. You can use them like any other reserved keyword, like we have done here or even here. So let's try it out. Let's say we only wanted to print to the console numbers that are odd. There are two different ways to achieve that. The first one would be to use an if statement. So if number is not divisible by 2, then we can print to the console the number itself, and then we can add 1 unit to the number. If I run this code, as we can see, it only printed those that are odd. However, for the sake of this example, let's use the continue keyword. So an alternative way of doing this, I'll delete everything, is to simply do if number is divisible by 2, then add 1 to the number, and then continue. And if this condition is false, then we can print the number itself and also add 1 to the number. So if I save this and execute this code again, as we can see, we still get the same result. But how does this work? Well, the continue keyword is telling JavaScript to skip whatever comes after it and go back right away to checking the condition and running the rest of the code once again. So obviously, if we were to specify continue at the beginning, then this is going to be unreachable code. And it makes sense because, well, we're continuing every time this while loop executes. And it makes sense because continue is going to make the while loop skip whatever is after this statement. So let's try it out. If I execute this, we get nothing logged to the console. However, it seems to be running for forever. And we can tell because, well, finished wasn't logged to the terminal. And the reason is because, well, we're not modifying number. So we have essentially created an infinite loop, a loop that will never stop executing, blocking all of our code. So it's important to be wary of how you control your while loop. You need to make sure that this condition within the while loop can result in false. It should never be true for forever. Otherwise, you can cause your program to freeze or to crash if you're not careful. And what can we do in this case? How can we stop the while loop from executing? Well, we can kill the process. We can exit this process right here. And to do that, you can use the shortcut Ctrl+C. And as we can see, it stopped executing the code. But let us now take a look at the break keyword. Suppose we wanted to stop this while loop from executing for good, not continue, because, well, we learned that it will still cause the while loop to continue executing. To do that, well, it's pretty self-explanatory. We can use the break keyword instead of the continue. So if I were to change this to a break, well, it would cause the same, but instead of executing this while loop for forever, it will only execute once. And we can test this. So if I save this file, open up the terminal, and execute the JavaScript, we can see that we only get finished. But we can obviously use it within another condition. So suppose we wanted to break out of this while loop if the number is equal to 4. So break. And if I save this file, execute the code, we can see that it only printed 1 and 3. So now that we understand how while loops work, I think it's time for a challenge. See you in the next lecture. Actually, before showing you the challenges, I forgot to show you about the do while loop. So the do while loop is simply a variation of a while loop that executes a block of code at least once and then repeats it as long as a condition is true. So let's take this for example. So while false, so we know this will never be executed. And we log to the console hello world. And if I save this file, compile it to JavaScript, and then execute the JavaScript, we see nothing in the terminal. And that makes sense. But what about this do while loop? Well, for this, you use the do reserved keyword, then the block of code, then inside do while, and then we specify the while right here. So while false. And if I do this and save this file, execute this code, we can see that it printed this inside do while at the very least one time. And that is, well, because the do while will execute this block of code at least once, as opposed to the while loop. If this condition is false, then this will never be executed. Or, well, until this condition is false, of course. And we can test this with numbers. So let's say let counter is equal to 1, and then we can change this to well, counter is less than 1, so this is not inclusive. And if we change this to be the exact same, save this file, execute this code, we can see that it printed inside do while. But if I change this to be -5, and we need to make sure to modify counter, and then let counter2 is equal to -5, and change this to counter2, and do the exact same, save this file, execute this code, we can see that, well, we got the exact same result. We got 6 here, and we got 6 here. So now that you understand how the do while works, we can move on to the next lecture. Let us now solve a challenge. So let's start with the first one. Write a program that uses a while loop to calculate the average of all the numbers between 1 and 100 inclusive. Give it a try. For this, we need two variables. The first one, which takes the count of which number we're in currently, and the second one, well, which is the total sum. So we can write let total sum is equal to 0 and let counter is equal to 1. So while counter is less than or equal to 100, so remember inclusive, then we can add to the total sum the counter, and then we can add 1 to the counter. And after this, well, we can log it to the console. So total sum divided by 100, because, well, it's a total of 100 elements. And if I save this file and open up my terminal, clear this and write the JavaScript, we can see that it is 50.5. So as we can see, the solution is correct. So let's move on to the second challenge. Write a program that uses a while loop to calculate the average of all of the numbers between 1 and 100, inclusive, except for 55. So as we can see, it is pretty similar to this one. Give it a try. For this, we can use an if statement, and if the counter is different from 55, so the current number is different from 55, we can add this number to the total sum. Otherwise, don't do anything but still increment the counter by 1. So we can write if counter is different from 55, then execute this line right here. Otherwise, we'll just increase the counter either way. And if I save this file, open up the terminal and execute this code, we can see 49.95, which is correct. And finally, the third and last challenge. Write a while loop that logs numbers between 1 and 10 in reverse. So in other words, 10, 9, 8, and etc. Give it a try. So we have to reverse the condition. So instead of checking for the bigger number, we need to check for the smallest number. So I'll delete this total sum. We don't need it anymore. And I'll come here and change this to be greater than or equal to 1. And instead of adding to the counter, so right now this is going to run for forever, we can change this to be -. And we can log this to the console. So remember, by having it as a postfix, it is going to log the number to the console first and then do the operation. So let's test this out. Let's save this file, open up the terminal, and then execute this code. As we can see, we get 1. And why is that? Well, that is because we're starting from 1, not from 10, as the challenge suggests. So we need to change this to a 10, save this file, and execute this code once again. And as we can see, we got from 1 to 10, but in reverse. So hopefully you were able to solve this challenge. If not, don't worry, it's all about practice. I have created a lot of challenges throughout the course so you can get used to the language and its syntax. We can now proceed to the next lecture. Let us now take a look at switch statements. So what are switch statements? Well, they are simply a way to execute different blocks of code based on the value of an expression. And it's particularly useful when you have to deal with many different conditions. So suppose we have the day of the week, so is equal to 3. And we wanted to log to the console the corresponding day to this day of the week. For that, we could use if statements. So if day is equal to 1, then we can log to the console, it's Monday. and then else if they is equal to 2, and so on and so forth. But this feels quite verbose. We have to use a lot of else if statements. And let's say we have Tuesday and we worked ourselves up to the 7th day. And suppose this could be another number, perhaps 0, perhaps 9, 10, 11. Well, for that, we would have a fallback for the case that this number does not correspond to any of these conditions. And for that, we would have the else statement. So else, and then log, this is not a valid day. But again, this is redundant in a way because we are always checking for the same variable. Wouldn't it be nice for there to be a way to simply specify the variable we want to switch upon, and depending on the number, we can simply log to the console? Of course there is, and that is using this switch statement. So let me comment this out. The equivalent would be to do switch day. And we specify these brackets right here, and then we can use the special keyword case. So in the case that day is 1, then we can log to the console Monday. And then we have to break out of the switch. And I'll show you what happens if we don't do this. So let's say case 2, then Tuesday, case 3, then Wednesday. And for now, let's keep it simple. So default, this is not a valid day. Now, if I save this and I execute this code, we can see that we get Wednesday, but also this is not a valid day. And what if I change day to be 1 instead of 3 and save this, execute it? We can see that we get Monday, Tuesday, Wednesday, and the default case. So this is why it's important to break right after specifying each case. So break, then break here, and finally this one right here. Now we don't need to break out of the default case because it's the last one in the list. There is no fall through. Now if we do this and execute this code, we can see that we only get Monday. What about a number that is not valid? As we can see, we get this is not a valid day. And you can actually use brackets which denote a block of code for the cases themselves. Now this will have no effect on how the switch statement behaves, but it can maybe make things clearer. For instance, in this line, line 12, I can use brackets and then close this logic within these brackets and do the same with the other ones. And as we can see, if I save this file and run it, we still get Monday. So now that we understand how switch statements work, I got a challenge for you in the next lecture. Let us now try and solve these two challenges. So the first one, write a switch statement that evaluates a variable that represents a grade. So A, B, C, D, or F. For each case, log a string to the console that tells the student what grade they received. If it is an A, congratulate them. If it's an F, tell them to try harder. If it is anything else within the valid grades, tell them they did okay. Otherwise, log an error message indicating that the grade is invalid. Give it a try. For this, I'll create a variable, let grade is equal to B. Now the reason I use let instead of const for this particular case is because since this can change and it is not eternally bound to this value, then it won't show an error when we try to compare this variable to another value that is not B. However, you should never ever use let if you're not going to reassign this variable. Then we can write switch grade. And in the case that it is A, then we log to the console, congratulations. And then we need to break out of this case so it doesn't fall through. Here's something interesting though. If we take a look at the instructions, it says if it is an F, tell them to try harder. Otherwise, if it's anything valid within the valid grades, tell them they did okay. So we can actually use fall through cases to our advantage, so we don't repeat our code. So here we could write case F, then log to the console, try harder, and then we break out of this case, and then we can use these fall through cases. So case B, then case C, and finally case D. And here we can log you did okay. And then we break out of these cases to avoid executing the default logic. And here we can write invalid grade. And if I save this file, compile it to JavaScript, and run it with B, we can see that I get you did okay. What about C? You did okay. What about D? Should also get the same output. And what about A? Congratulations. And what about F? Try harder. Let's now move on to the second challenge. Write a switch statement that evaluates a variable that represents a day of the week. For each case, if it is a weekend day, log weekend. Otherwise, log weekday. If it is not a valid day of the week, log an error message indicating that the day is invalid. Give it a try. For this, let us get rid of all of this code, and we'll change this variable name to be day of week. And this is going to be equal to Monday for starters. And then we have to switch upon these variables. So day of week, and then we can use fall through cases. So case Saturday and case Sunday. We can log to the console that this is in the weekend. Otherwise, well, we can do it with Monday, Tuesday, Wednesday, weekday. And then we break out of here to avoid falling through the default case. And then we can log error invalid day of the week. And if I save this file, compile it to JavaScript, so make sure you're compiling to JavaScript, then open up the terminal, I'll clear the terminal, and then if I run the JavaScript file, we get weekday, so Monday is a weekday. What about a Saturday? If I save this file and execute this, now this is going to be weekend. And let's give it one last try with Thursday, so let's copy this value, paste it in here, save this, and we get weekday. And what about something that is invalid? So perhaps Thursday with a number? We get error invalid day of the week. So now that we have learned how to use switch statements, when should we use them? Well, you should use them whenever you have to deal with multiple conditions based on a single value. Now, some people detest using switch statements, but personally, I think they offer great readability and conciseness, which is always welcomed. However, it depends entirely on you. The more you practice, the more you'll learn about best practices and whatnot. Having said this, see you in the next lecture. Let us now take a look at for loops. So for this, I created a simple little example using the while loop. Now this example has a very important component, and that is, well, the condition depends on a fixed number. So we know this while loop will break once the value reaches 100. But I told you while loops don't necessarily have to use numerical values. It can actually be based on another condition. Perhaps you have a request that goes to a server and asks for some information, or you want to send information to a server. So you may have requests. Now this can be either null or of type string. And let's say it's null at the very start. And then we could have a while loop while request is different from null. Then get data from the server until it is not null anymore. But when we are dealing with a case where we know the size is fixed, we can use the for loop. So instead, I'll write it here. A for loop looks like this. So we have for, then parentheses, and instead of the condition, we initialize the variable. So in this case, it's this value right here. So we can define let counter is equal to 0, then semicolon, then the condition. So value is less than or equal to 100. And then we specify how we will modify the counter. So in this case, we may have counter plus equals 1. Or well, in this case, we can simplify it to this increment operator. And then we have the body, which will be executed per each iteration. So remember, iteration refers to the process of repeatedly executing a block of code. So we can rewrite this to look like this. For let I is equal to 0, then I is less than or equal to 100, and then I++. And inside here we could perhaps log to the console. So log for loop, and then we pass in I. And if I save this file, let's get rid of this code and open up the terminal and execute the JavaScript. Well, we can see it printed from 0 to 100. So in essence, we achieve the exact same as if we were to use a while loop. However, this is more concise because for loops are designed for fixed numbers. Whenever you have a condition that involves a number like this one, always opt in for loops. You shouldn't really use while loops for those cases. And actually, it's quite uncommon to use a while loop. For loops are used more due to loop conditions generally being based on a predetermined number of iterations, while loops are used more when the condition depends on external factors and isn't based on a simple range. However, we'll see common use cases in the future sections. Having said this, now that we understand how for loops work, we can move on to a challenge. Now, in this lecture, you'll try and solve these 3 challenges. These ones are pretty much the same as the while loop challenge, so they should be a breeze. Let's start with the first one. Write a for loop to calculate the average of all of the numbers between 1 and 100, inclusive. Give it a try. For this, we need a variable to keep track of the total sum. So let total sum is equal to 0. Then we can use the for reserved keyword. Then we can initialize the counter itself here. Let counter is equal to 1. Then while counter is less than or equal to 100. And then counter plus plus. And inside here, we can add to the total sum the counter, or well, the current iteration. And then we can print to the console, average is total sum divided by 100. And if I save this file, open up my terminal, we can see that we get 50.5, which is correct. So now we can move on to the second challenge. Write a for loop to calculate the average of all even numbers between 1 and 100, inclusive. Give it a try. So there are 2 approaches for this. The first one could be if counter is even, then we can add it to the total sum. And then, well, we take half the number, so divided by 50. And if I save this file, open up the terminal and do the same, we get 51. But the other approach is to modify this one right here. So instead of adding 1, we add 2. So counter plus equal 2. And then we need to start at the number 2, just to make sure we're not adding the incorrect values. And we can get rid of this if statement since it's redundant. And then if I save this file, open up the console, and execute the file, we get the exact same answer. So both are correct. Perhaps the if statement is clearer, and you don't have to think too much what this for loop is doing exactly, but both are valid anyway. And lastly, write a for loop that logs numbers between 1 and 20 in reverse. So 20, 19, 18, etc. Give it a try. Well, this one's pretty basic. I'll get rid of all of this. Then write for starting at 20, and then while I is greater than or equal to 1, and then we decrease it by 1. And then we can log the number. And if I save this file, open up my terminal, clear the console, and execute the file, we get from 20 down to 1. So as we can see, for loops are easier to read and they are more concise. But anyway, now that we understand how for loops work, we can proceed to the next lecture. Let us now take a look at the ternary operator. Now, the ternary operator is an alternative for the if statement. But opposed to an if statement, you will always need to specify the else when using the ternary operator. But the ternary operator is particularly useful when you want to assign a value to a variable conditionally. So suppose you have a variable, so age is type null or number, and it is null for some reason. Maybe you're receiving input from a web application and the age is not required, but you wanted to check if the user is an adult and assign that boolean to a variable. To do that, you could perhaps create the variable so it's adult and it's false at the beginning, and then check if age is different from null, then assign is adult to true. However, this takes up a lot of lines and it isn't very clear. Maybe you have more complex logic within this block. So at first glance, you cannot tell when is adult being modified. For that, you can leverage the ternary operator and simplify this code further by changing this. So I'll comment this out. Let is adult is equal to, and then check age is different from null. If it is, then check is age greater than or equal to 18. Otherwise, leave it as false. And if we save this and print this to the console, and let's say this is going to be 18, and actually change this to be a constant, same with is adult, compile the code to JavaScript, and then execute the code, we can see that we get true. So what happened is, well, it came here to the condition, and since 18 is different from null, then evaluated this one right here, which returns a boolean, either true or false. Otherwise, default to false. So it's the exact same as if we were to do this right here, but instead of true, obviously it's going to be age is greater than or equal to 18. But again, this is more concise. It is all within a single line, and you don't have to declare this as let. So it is very clear that you will not be changing the value of this variable starting from line 10. As opposed to this, you could say, okay, it is a let because then we change the value depending on this logic right here. But what about all of the lines that follow this one? The reader might be wary of when and if it's going to change later on. So that's why I prefer to use const whenever possible. And actually, well, a ternary operator, as opposed to an if condition, returns the values. So it returns either this expression or this expression for us to use. That is why, well, we can assign it to this, because after all, it is going to return a boolean. If we take a look at here, well, this is going to be either true or false, or, well, false itself. And if I hover over is adult, we can see that its type is boolean. That means we can use it as any other statement. We can actually copy all of this logic right here and paste it within the log. And if we do this and execute the code once again, we still get true. And that is something very important to understand. So now that we understand how this ternary operator works and how it is useful, prepare yourself for the next lecture because I've got a challenge for you. So here's the classic challenge, FizzBuzz. Write a program that prints the numbers from 1 to 100, but with a twist. For numbers divisible by 3, instead of the number, print fizz. For numbers divisible by 5, instead of the number, print buzz. And for numbers divisible by both 3 and 5, instead of the number, print FizzBuzz. Give it a try. Okay, for the solution, there are multiple ways to solve this. You can use a while loop, a for loop, you can use if statements, the ternary operator, or even the switch statement. But I'll show you 3 different approaches so that you can get used to the switch statement and the ternary operator. So the first one, which is the most straightforward one, would be to use a for loop. So from I starting from 1 up to 100, we can simply check. So if I is divisible, so let's start with the first one, divisible by 3, then log to the console, fizz. Otherwise, so else if I is divisible by 5, then log to the console, buzz. And if neither of these are true, then log to the console, FizzBuzz. But obviously you have to account for the ones where it's neither by 3 nor 5 nor both 3 and 5. So we need to change this to be an else if. So if I is divisible by 3 and I is divisible by 5. And then we have the default case. So log to the console I. Now if I save this file and execute the code, we can see that we get a lot of FizzBuzz and the numbers. But there is no FizzBuzz concatenated. And why is that? Well, remember, if the number is divisible by 3, then that means that this condition is unreachable, same as this one. Because for this to be true, then these two are true either way. So that's why this has to be the first condition. And this is the trick of FizzBuzz. It is to see if you understand the control flow of if statements. So for that, well, we can simply copy this condition right here, paste it here, and then we can check for 3 instead. So FizzBuzz, then this is going to be fizz. And finally, we have to check for 5, and this is going to be buzz. Now, if we save this file, execute the code, we can see that we now get FizzBuzz multiple times. So the solution works. However, there's a different way to tackle down this problem, and that is using the switch statement. So for that, what would be the condition? Well, we're switching on true because we wanted to evaluate each case independently. So we can use switch true. Now, this is not a good practice. You should never use the switch statement like this. However, for demonstration purposes and for learning purposes, I'm going to show you how to use the switch statement. So for this, we can use case, and if I is divisible by 3 and I is divisible by 5, then execute this piece of code, and this is going to be FizzBuzz. And we can do the same with the other one. So divisible by 3, then log fizz, break, and then case where it's divisible by 5, buzz, break, and the default case is going to be, well, the number itself. Now, if I save this file and execute the code once again, we get the exact same output. And why is this working? Well, because this is a condition. This is going to evaluate to either true or false. So it makes sense that we can use this within the cases. It's a value, after all. You should always be thinking about what this is going to evaluate to. Since we're using conditions, it can only be true or false. And the last solution is using the ternary operator and condense all of this logic within a single log. But how can we achieve this? Well, that's because you can actually nest ternary operators. So let's go back to our solution where we used if statements. And let's comment this out and try to replicate it using a ternary operator, but this time nested. So we can log to the console. I is divisible by 3 and I is a multiple of 5. If it is, then we use the question mark where this will be executed if it's true, or rather return if it's true. Otherwise, here we can specify the other condition. So we evaluate this one right here. Is I a multiple of 3? If it is, then it's going to be fizz. Otherwise, check for multiple of 5. And if it is, we have buzz. And remember, the ternary operator always needs a final else. So here we use colon and then I itself. And if I save this file, come back here and let's clear this, execute the file, we can see the result is the exact same. So which of the three should you use? This one. This one is confusing, and for the switch statement, do not use that. That is bad practice. You should always be switching upon a value. You should not use switch true and then create your own separate and independent cases. So having solved this challenge, we can proceed to the next lecture. Now let's take a look at scoping and hoisting in JavaScript. So what is a scope exactly? Well, it is simply a part of the code where a variable can be accessed or referenced. In JavaScript, we have three different types of scopes. The first one is the global scope, which is the one where we define the variables in the top level of scopes. So in this case, X is defined in the global scope. We then have the block scopes, that are those created when a block of code is enclosed by curly braces, such as when we use an if statement. So whenever you see these curly braces, they are defining a block scope, as simple as that. And then we have the third one, which is a function scope, but we'll learn about that later on. When we declare variables using const or let, we can only access them within the block that they were defined or by other blocks nested inside it. So as we can see, we can access this variable x inside this scope, but we cannot access y in the global scope, which makes sense, as if you define a variable within a scope, then that variable pertains to that scope. But as we can see, if we nest the scopes, we can still access those that live inside these other blocks. So I can create another block, and another one, and another one, and if I log to the console x and y, we can still access these too. But obviously, if I were to define another variable z is equal to 30 and try to access it within this block, we get an error saying z is not defined. But this only happens when we use const and let. So let's try it out with let. We get the exact same result. But what about var, which is the old school way of doing things? As you can see, we can still access and reference these variables in scopes that shouldn't have access to these ones. As we can see in line 17, we are accessing x, which is defined in the global scope, but y is defined within this block scope, but we can still access it. How does this work internally? Now, I won't go over the details because it is a concept that you shouldn't really be thinking about, and especially if you use let and const. However, to understand at the very least this behavior, this is called hoisting. Hoisting is a feature that moves variable and function declarations to the top of their respective scopes before the code is executed. So what this is doing essentially is taking, for example, let's get rid of this x and define it after accessing this variable, and as we can see, we get undefined. So as hoisting suggests, it is taking this variable right here, this identifier, and before executing the code, defining it up here. So in this case, it is undefined. And once it reaches line 18, it will assign to x 10. So it's basically like if you were to do x is equal to 10. So that's why we can still use x even though it was defined after referencing this variable. Fortunately, the TypeScript compiler throws an error and tells us that the variable x is used before being assigned. But this won't stop the code from executing. It will still run just fine, as we can see through the Quokka output. So this is another reason to steer clear away from using var and stick to let and const. Let us take a look at functions. Functions are one of the most fundamental concepts in programming. A function is a block of code that performs a specific task and can be reused throughout your program. You can think of a function as a factory or a machine that takes some input, does something with it, and produces some output. For instance, let's say we have a function named addNumbers that receives two inputs, so we have a and b. Now these are known as the arguments of a function, also known as parameters. However, technically speaking, these are arguments, though both are valid. We then have the body of the function, similar to an if statement, where if condition, then do something. So in this case, we add these two numbers. And then we have the output, which is the result of a plus b. And this is referred to as the value that is being returned from this function. So now let's jump right into the code. So let's replicate this addNumbers function. For this, we can use the reserved keyword function, followed by the identifier, so in this case addNumbers, camel case, and then we need to use parentheses. And within these parentheses, we can specify the arguments. So A of type number, B of type number, and then we can use the brackets to specify the body of this function. And within this body, we can create const result is equal to A plus B, and then return the result. Now, how can we use this function? Well, for that, we can log to the console the result of addNumbers. What happens if I pass in the identifier? As we can see, we get lambda addNumbers. And that is because we're referencing addNumbers. We're not calling or invoking this function. So how can we invoke this function? Well, if you haven't noticed already, we are already invoking a function. And that is with this log right here. If you're using the same theme as I am, functions will have this orange color. So it's easy to identify what's a normal variable and what's a function. So we can come here and simply open parentheses. And if we do this, well, we get an error saying expected 2 arguments but got 0. So as we can see, the first one that we pass in corresponds to A and the second one to B. So we can pass 1 and 2. And as we can see, we get a number back. And this is something very important to consider. The arguments must be in order. So 1 corresponds to A, 2 corresponds to B. What if we were to omit one of them? If I delete 1, leave the comma, and then 2, as we can see, now the 2 will correspond to A, since it's the first argument passed. Now, why do we get not a number? Well, if we log to the console A and B, we get 2 and undefined. So that means even if we don't pass arguments that are required to a function, it can still run. But obviously, you will get unexpected results. But soon enough, we'll see how we can make these parameters optional. But for now, understand that when you open up the parentheses, you're invoking a function. And most of the times, the function will return to you a value. But how can we see what is a function returning exactly? Well, if we hover over addNumbers, we get A, which is of type number, B of type number, and then this right here denotes the return type of the function. So what if we copy this and paste it right after the parentheses? As we can see, well, we get the exact same result. But now, instead of letting TypeScript infer the return type automatically, we are enforcing this function to always return a number. So that means if I remove this return statement, we get an error saying a function whose declared type is neither void nor any must return a value. So that means we must follow the return type. If it is number, string, boolean, then it must return one of those values always. But here we have void or any. Now any, we learned that is basically JavaScript's world. It allows you to omit data types and do whatever you want. But again, well, we learned that since we're in TypeScript, it makes no sense to use any. Otherwise, well, just stick to JavaScript. But what about void? Well, void is another data type that is really only used for functions. So you can specify the return type to be void. So in other words, a function that doesn't return anything. And this works because a function doesn't need to receive an input, nor does it need to return something. In fact, we can get rid of these arguments and just print to the console inside addNumbers. Now we must remove all of these arguments, and as we can see, well, we get undefined back. Because since the function is not returning anything, then the data, the return, is not defined. But as we can see, by invoking this function, well, we print to the console inside addNumbers. What if we just point to it, just reference it without invoking it? As we can see, it doesn't print anything to the console. But we can actually invoke it multiple times. It is not restricted to one single time. So if I invoke this function, duplicate it a couple more times, well, per each invocation, we get one corresponding log to the console. And actually, if we take a look at this log function, we can see that its return type is void. So in other words, it is returning undefined. But if void returns undefined, then why does void exist? Why can't we just use undefined instead? Let's try it out. Let's change this void to undefined. If we do this, well, we get an error stating that we need to return a value. And the reason this exists is because suppose you want to pass in a number, so a is of type number, and if a is equal to 0, then you can return undefined. Otherwise, you could return a number, so now this becomes a union. So undefined, number or undefined, and we return a times 2. Now this is a silly little example just to showcase why void exists. Of course, we would need to pass in a number, so 1 or 0 is valid. But now we know that this function can either return a number or undefined. So void is simply that placeholder to denote a function that shouldn't return anything, period. While undefined should be used in those cases where you're going to explicitly return undefined. Now this perhaps might seem like weird behavior. Some people would prefer for undefined to be synonymous with void, but it helps with clarity, so it is what it is. With that covered, let us proceed to our next lecture. Now let's take a look at guard clauses. So what are guard clauses? They are simply a method for us to get out of the execution of a function if a condition is not met, in order to avoid nesting conditions. So let's say we have a function. We want to subtract two numbers as long as the first number is greater than the second number, and both numbers must be positive. You could write function subtract numbers. Then we have a of type number, b of type number, and we're going to return either number or undefined. So for the case where a is less than b, then undefined, or if either of them are negative, then return undefined. So you start nesting if conditions. Of course, you could do it all in one pass. So you could say, okay, a must be greater than b, and a must be greater than 0 and b must be greater than 0. Or you could have them separately. So you could take this logic right here, remove the and then define a nested if statement. And here you could write a minus b, and then you could return undefined. Now this is something I didn't show you. You do not need to use the else. And the reason is because the return statement acts like a break. So once it reaches this line and this condition is true, it returns immediately, resulting in the function bailing out of whatever continues. So this line is unreachable, basically. So that's why specifying else is redundant. However, this isn't very clear. We're dealing with the conditions right here, nested, so that makes it harder to read. What if there were 4 or 5 more conditions to consider? And then at the last line, we deal with the cases where all of this is invalid. To simplify this, we can use guard clauses. So instead of doing it inverted, so we check for the validity of each condition, and if they are valid, then return the result. We do it inverted. So we check for invalidity, and then at the very last line, we return the result of the subtraction. So I think this is a pretty good challenge. Pause the video and give it a try. For this, I'll comment this logic just to have a reference point. And what we can write instead is, instead of checking if a is greater than b, we check if a is less than b. So if a is less than b, or if a is less than or equal to 0, let's add that equality, or if b is less than or equal to 0, and in this case, return right away. And notice I did not specify undefined, and that is because this is a shorthand for return undefined. So we can omit undefined and save us a little bit of time. And there is another way to make this even more concise, and that is removing these brackets. Since we only want to execute a single line if this condition is true, then there is no need to specify brackets because the brackets are used when you need to take up more than a single line. So instead, I can delete all of this and simply specify return. Now, important here, you could do whatever you want as long as it is a single line. You can even print to the console if you wish. But in this case, well, we want to bail out of the function right away. And then we can change this to be a minus b. And if I save this file, well, we just achieved the exact same thing. So this one is definitely more readable. So let's see if it works. Let's print subtract numbers. And we pass in 8 and 3. Now this is 5, so this is valid. What about the case where these two are equal? So 5 and 5, we get 0. And what about a being less than b? Well, it should bail out. Let's see. 2 and 5, we get undefined. And what about if both of them are undefined? Subtract numbers. -3, -4, we get undefined. And lastly, let's see if one of them is negative. So -3 and 5 yields undefined. But now let's see what happens if we compile this code to JavaScript. So open up your terminal, type npx tsc, and then if we open our JavaScript file, we can see that, well, we lost all type annotations. But what happens if we perhaps pass in a string, maybe 5, and save this file? Let us run again tsc. And if I go back to our JavaScript, we can see that it is using a string and there's no error in the JavaScript file. And it makes sense because, well, a is any by default in JavaScript. But we at least get a compile error. And it says found one error in script.ts. But it still compiled it to JavaScript. So what can we see here? Well, that is, JavaScript is not enforcing any types. So even though in TypeScript, if we pass in a string instead of a number, we get an error. But nothing is making sure that in our runtime, once the code is executed, something is checking that this is a number and this is a number. So there's always the possibility that the data that you're passing to a function is invalid. And what can we do in that case? Well, for that, we can use the type of operator. And this type of operator returns to us a string, telling us the type of the variable that we passed in, or the value. So if we pass in a number, then we get number, we get a string back saying number. If it's a string, then we get string, and so on and so forth. So for this, we could also use type guards to make sure that we're bailing out before we get, let's say, not a number as a result of this subtraction. Although, to be fair, we're using these number comparators. But anyway, it could happen with other data types. So we could get rid of these comments right here and use the type of operator. So check if type of A is different from, and we get autocomplete. So in this case, it's going to be number. Or if type of B is different from a number, then we can return immediately. And if I save this file, compile it to JavaScript, and come back to this JavaScript file, well, at the very least, we're making sure that in JavaScript, we're not allowing invalid data types to be passed to this function. But obviously, this becomes very tedious because that means we have to check for the validity of the data types every single time, everywhere. Now, there are validators such as SOD, which we'll see later on. But for now, as long as you're writing code contained where you're not receiving input from an external source, it is totally fine to get rid of this validation. In fact, it is not needed. But whenever you're dealing with, let's say, a form in a web application, or you created a server where anyone can send anything to that server, then you should obviously always validate everything, even the data types. Because as we can see, TypeScript only does that for our developer experience. But in the end, JavaScript has zero way of telling if A is a number or if B is a number. So now that we have learned how guard clauses work, we can move on to the next lecture. So now I have 4 challenges for you. Let's start with the first one. Create a function called calculateAverage that takes into numbers as arguments and returns their average. Pause the video and give it a try. This one's pretty basic. We can create the function, calculate average, then number 1 of type number, number 2, and we will return a number. And then return the sum of these two numbers divided by 2. And if I save this file, and let's try it out, so 4 and 5, and log this to the console, we get 4.5. Now let's check out the second challenge. Create a function called addStrings that takes in two strings as arguments and concatenates them together. Pause the video and give it a try. Well, for this, let's create a function addStrings, then A of type string, B of type string, and we return a string. And here we can either do A plus B, but remember this is more for arithmetic operations. So let's use the template string instead. So A and B without the space. And we can add these two addStrings. So let's log this to the console. Hello world. Now for the third challenge, create a function called the square that takes in a number as an argument and returns the square of that number. Pause the video and give it a try. So let's create the function. So function square, we take in a number, so type number, and we return a number. And for this, we can return number times number. And let's give it a try. Let's print to the console the square of 2, which is 4. And finally, the fourth challenge. Create a function called sum of squares that takes in two numbers as arguments and returns the sum of their squares. So a simple test case, sum of squares of 3 and 4 should return 25, because 3 squared plus 4 squared is equal to 9 plus 16, and this is equal to 25. Give it a try. Now for the solution, I expected you to use this function. Why repeat code when you already have a function to do that specific functionality? So we can come down here and write function sum of squares. So A type number, B type number, we return a number. And here we can simply return the invocation of a square and we pass in A. And then we sum with the invocation with B. So remember this, if I hover over square, it returns a number. So you can treat it like any other number as long as you invoke it. And if I save this file, come down here and check out with the example. So sum of squares of 3 and 4, we get 25. So as we can see, functions are extremely useful to avoid code duplication. The moment you need to duplicate code, extract that to a function and invoke it wherever you need it. Having said this, we can proceed to the next lecture. Let us now take a look at parameters passed by value. Now what does this mean? This means that when a function is called with arguments, the function only gets to know the values of these arguments. So that means if we modify the arguments, it is only affecting these arguments, instead of the values we passed directly when invoking this function. For this example, I have illustrated the stack. So what is the stack? When you execute code, JavaScript must keep track of the functions and variables being used in a special area of computer memory called the stack. So if we take a look at this demonstration, we have declared two variables. So we have x, which points to 5, and y, which points to 10. In the stack, it would be illustrated like such. So we have y, which is the identifier or the key, and we have its corresponding value. Same with x. That means JavaScript, whenever we reference x via its identifier, it can simply look up x in the stack and can use its respective value. But the stack is used when the size of the data is known beforehand. So in other words, when the data is static. Data that is static or is fixed could be numbers, could be booleans, pretty much primitive data types. But in the case of non-primitive data types, such as arrays, which are a list of elements. So in an array, we could have 3, 5, and 7 within a single identifier. Instead of declaring 3 different variables, it creates a list of elements. And a list of elements is dynamic. That means that this list can shrink or grow. Or in other words, you can remove and add elements as you wish. In that case, since it is not fixed, it is not static, it must allocate memory in another place called the heap instead of the stack. And opposed from the stack, the heap can grow and shrink as well. But we'll see what that means later on. For now, let's focus on the stack. So if we come down here and look at this example, we have declared the exact same variables. But in this case, we have a function, modify numbers, that receives 2 arguments. So we have A and B. And inside of this function, we're modifying directly these 2 arguments. Now you perhaps would expect that if we invoke this function by passing x and y, this function will modify x and y as well, not only its arguments. And that is false, because in the stack, it allocated memory for both y and x, but for the scope of this function right here at numbers, this should be modified numbers, it allocated new memory. So it created, to say, another identifier pertaining in particular to this function, and stores its value. So when you modify these arguments within the function, you're modifying those that are stored for the function and not the ones that you used to invoke this function. So let's take a practical look. If we come here and declare a variable, so x is equal to 5, then a function, modify number, and we accept y, which is of type number, and we return void. Inside here, we can modify y directly and add 10, for instance. If we do this and log to the console x and then invoke this function, so we pass in x and then we log x once again, and if I come here and log to the console y, we can see that it affected only y and x is intact. So remember, this allocates new data in the stack instead of pointing to this one, which happens in the case when we use data that is stored in the heap. But we will learn what that is later on. And another thing that I forgot to mention is that you can actually name your arguments the same as any other variable that lives outside of that function. So we can rename y to be x. And if we do this, we are still referencing x. Now, how is this possible? Well, remember, it is creating or allocating this data for that particular function. So in that case, y is not duplicated per se. And if you're using my theme, arguments are colored with this green. So it's very clear what you're dealing with exactly. Having said this, we can move on to the next lecture. Now here I want to show you why JavaScript is a very flexible language. In JavaScript, you can assign variables, any type of data that you can imagine. We have already dealt with primitives, which encompass number or booleans and so on and so forth. And these are the basis for everything. But we also have functions, and functions are data types themselves. So they can be assigned to variables declared with const, let, or even var. So if we declare a regular function, we specify the identifier, so x, we can then reference x via its identifier, obviously. But let's try assigning it to a variable. So const y is equal to x. Now y is referencing x. So if I hover over y, we can see that it is now a function. And if we log something to the console within x, I'm in x. And then if we invoke y, as we can see, well, it invoked this function right here. And it makes sense since we're referencing x. Now, since we can reference other functions and give it to a variable, what about declaring a function for a variable itself? For that, we can declare const z is equal to, and then we use the function keyword. Now, in this case, you do not need to specify another identifier. And it makes sense because, well, since we are already assigning z to this function, why would we need to specify another identifier? So we can omit that and move directly to the parentheses. And here we can specify the return type if we wish. So in this case, let's do void, and then we can log to the console, I'm in Z. Now to invoke it, well, it's just a function, like this one. So we can come down here and just invoke it. So this is known as an anonymous function. And you can in fact change this to be a let and then reassign it. So Z is equal to now a number. Now, of course, TypeScript yells at us, saying that type number is not assignable to type, well, this function that returns void. But again, we learned that TypeScript can only enforce this on the developer side. Once you compile the code, all of this is gone. Fortunately, if you're using my theme, once again, functions are colored with orange, so it is very clear what you're dealing with. Now the question arises, when should I use this regular function declaration over this anonymous function? And the answer must be kept for later, once we dive into how we can assign complex data types to variables. See you in the next lecture. Let us now take a look at arrow functions. To define an arrow function, it is pretty much the same as an anonymous function, in the sense that we will be using a variable. So we can come down here and define const arrow function is equal to, and here we just specify the parentheses where the arguments go, and after this we specify a flat arrow, and then the brackets to denote the body of this function. So we can omit the function keyword and simply substitute for this flat arrow. But what about defining the return data type? Well, it's the exact same. So we can come here and specify void. And what about arguments? Well, the exact same. So a of type number, and then we can come here and print a. And to invoke this function, we just use parentheses and pass the value. And as we can see, well, we get 5. However, same as using if statements where we can omit the body, arrow functions allow us to do the exact same. Let us quickly recap. So if I do if true, then I can log immediately. To achieve the same using an arrow function, we just get rid of these brackets. And as we can see, we simplified it all into a single line. However, there is an important distinction between these two behaviors. Since an if statement executes code if the condition is true, arrow functions can return values. So if we use the syntax right here, how can we return a value? You might be inclined to use the return keyword. So let's try it out. Let's change this to be number and then use return 4. However, this doesn't work. The way to return something using this syntax is to simply get rid of the return keyword. And if we log the result to the console, we can see that we get 4. And you can obviously perform arithmetic operations here, so perhaps a plus 4. In the end, any expression that gives us back a value can be used as a return. And you can even return the invocation of a function, because remember, invoking a function returns a value, even if it's undefined. So if Z were to return a string, we could return hello world, and then we can change this type and return the invocation of Z. And as we can see, we get hello world back. Now that we have covered arrow functions in detail, let's move on to the next lecture. Let us now take a look at how we can type variables that hold functions. Well, if we hover over add, we can see that we have this type annotation. And in fact, it is extremely similar as this one right here. So TypeScript uses the arrow function syntax for typing out functions. So let's try typing this out explicitly. So we have a number, b of type number, and this returns a number. So we use the flat arrow instead of the colon for the return type. And it makes sense because the type is just there for helping us. It isn't the actual code that is being executed. So the TypeScript team opted to use this flat arrow to declare the return type. And if we do this, we can actually get rid of this right here, of this type annotation and the return type, since this is the one now giving the information to this function. And we can confirm this by hovering over A. We can see that it is of type number, same as B, and well, the result is a number. The syntax, however, only works for functions that are held by variables. You can't obviously use this type annotation for regular functions. Let's try it out with anonymous functions. So const subtract, and it receives two numbers. And then this is equal to a function that receives A and B and returns A minus B. And we need to specify the return type. So this is going to be a number. Now if I save this file, come here and log to the console, subtract 3 and 4, we get -1. But what if this function definition does not correlate to this type right here? Well, if we try adding another parameter, or perhaps try to override one of these type definitions, we get an error. So let's say A is now of type string. As we can see, TypeScript throws an error, saying that this type right here, so this function, is not assignable to type, this function right here. So there is a mismatch in the types. So when should you explicitly annotate your functions? Well, this is something you will not find much use as of now, but in the future, you'll see how powerful this is. Now I have 4 challenges that I want you to try and solve. Let's start with the first one. Create an anonymous function named length of string that takes in a string and returns the length of the string. So for example, length of string hello world should return 11. The idea here is for you to research online how to get the length of a string. And the reason I do this is because it is very important to be resourceful. A developer's best friend should be Google. So pause the video and give it a try. So the solution is pretty straightforward. We can define a function, const length of string is equal to an anonymous function that takes in a string and returns the a.length. As we can see, length returns the length of a string object. And then we can try it out. Length of string of hello world. And we get 11. Let's move on to the second one. Create an arrow function named max that takes in two numbers and returns the largest number. So for example, max 1 and 2 should return 2. Give it a try. Since we're using an arrow function, we can do it all in one liner. But I'll show you 2 ways to achieve this. The first one would be to create the function, first of all, a of type number, b of type number, and then check. If a is greater than b, then return a, otherwise we can return b. Now remember, we can omit the else when we're using the return statement, as it breaks out of the execution of the function. But the other way to do it in one liner is to use the ternary operator. So we can get rid of all of this code and simply write a is greater than b. If it is, then return a, otherwise return b. And if we save this file, well, Prettier added this parenthesis for us. So now we can try it out. So max of 1 and 2 is 2, and we can give it another try. So max of 2 and 1 is still 2. Now let's move on to the third one. Create a regular function named isEven that takes in a number and returns true if the number is even and false if it is not. So for example, isEven2 should be true and isEven3 should be false. Give it a try. This one is pretty rudimentary. We can define a function isEven, takes in a number, and returns a boolean. And here we can return num modulus 2 is equal to 0. And if we log to the console, isEven2, this is going to be true, and isEven3 is going to be false. And now the last one, create an arrow function named whatType that takes in an argument and returns the type of the argument. For example, if we pass in a number, it should return number. If we pass in a string, it should return a string, and so on and so forth. Give it a try. For this solution, we can use the type of operator. So const what type is equal to an arrow function. This receives anything. So let's say any and returns a string. And then we can simply use type of a. And if we log to the console what type 1, this is going to be number. And what about hello world, which is going to be a string. Having solved these challenges, we can move on to the next lecture. Let us now take a look at functions returning functions and type aliases. Just as we can assign functions to variables, then it makes sense that we can return functions within functions. And that's because a function is treated as a value. So let's try it out. I have a simple function, variable function, returns nothing, and I simply print to the console. Now if I were to define another function, perhaps a regular function, and I return this variable function without invoking it, and if I hover over regular function, we can see that it is a function that returns void. And why? Because, well, this function returns void. But what if I were to change this to be a number and return 5? Now if I come back here and take a look, it is now a function that returns a number. But what about this one? Well, it's a function that returns a function that returns a number. That means that we can invoke it twice, right? So let's give it a try. If I log to the console inside regular function, and then I come back here and invoke regular function. Now by invoking it, I'm getting this value in return. So I can actually assign it third function is equal to regular function. And as we can see by the color, it is a function, and also by its type annotation. And if I run Quokka, start on current file, we can see the output. But if I invoke third function, we can also get this output right here. But you can actually invoke functions consecutively without the need of extracting it to another variable. Because in the end, when you invoke this function, this gives you in return a function. So you can immediately invoke the function this function is returning. This might seem confusing, but let's take a look. If I delete this variable, come here and use parentheses once again, I'm invoking the function that is being returned from invoking this function. Now, I personally wouldn't recommend using this syntax. It's better to extract the functions into their own variables with good identifiers so that the reader knows what each function accomplishes. But unfortunately, there's bad practice everywhere. So it's very common for you to stumble across this syntax right here. And most courses don't show you this. So you're left on your own to understand what is happening. This is why I'm showing you that you can actually immediately invoke functions that return functions, since after all, they are just returning a reference to the other function. And this is obviously not restricted solely for two functions. As long as the function that you're invoking returns another function, you can invoke it. So let's say variable function returns another function. So you can type it out here. So let's say an arrow function that simply logs to the console. This is the third function. And if I come here, I can just invoke it because, well, let's recap. By invoking this function, it is returning this function. So we invoke that function. And now we have this function right here that we can invoke. So the return value. So in this case, if I invoke this, we get this one right here. However, we get an error. And it says type void is not assignable to type number because, well, we have this explicitly. So for now, let us TypeScript do the job for us and automatically type this out. And if I change this, now we can invoke this function. And if I were to assign this to a variable, so variable is equal to regular function, then this is going to be void, which we know is synonymous with undefined. But let us now try and type this out. So if we hover over this one, we can see that it is returning a function that is returning a function that is returning void. Now this is extremely confusing. So let's keep it simple. Let me get rid of this here and of this invocation, and let's get rid of this variable. Now if I hover over this one once again, well, we can see it's just a function returning a function that gives us a void. But let's change this to be const. So const regular function is equal to a flat arrow function. And now let's copy this type annotation right here and paste it here. And this makes sense, well, because this regular function is a function in itself. So remember, this signature right here denotes a function. And then after the flat arrow, we specify what it is returning. So in this case, since this is void, then the type annotation is simply, well, the function that accepts no arguments. So we leave this empty. And then since it doesn't return anything, it is going to be void. So it's just about changing this value right here and start thinking about functions. So you would have to replace this to the signature of a function that returns something. And this something, well, depends on your function. In this case, this function is void. So it makes sense that we can specify this as a function. So this is the function that returns a function. So this one right here that returns void. But this starts getting really confusing. What if this function returned another function? For that, I want you to give it a try. Pause the video and try it out. So let's say this function returns another function that returns void. So we would have to change the signature right here to a function that returns void. Then we need to satisfy this by typing a function that returns nothing. So third function. And if we want to type this one out, then we know that this is a function, right? That returns a function, but this function is returning another function that returns void. So we can actually copy this and paste it here. And as we can see, well, it works and it makes sense. But again, this starts getting really confusing. So a way to extract all of this so it is clearer is by using something called type aliases. Just as we have the type alias, so this is a type alias basically, where we have x is of type string. Now this one right here is a type alias. Wouldn't it be nice to extract this to our own type? And we can just assign it here. Well, for that you can use the special keyword, which isn't reserved because it exists solely in TypeScript. So as we can see, this string only exists in TypeScript. That means we can name a variable string and we don't get an error, because since this is compiled to JavaScript, this type annotation disappears. So the same thing applies to types. So we can use type, even though we could name a variable type, and then we can give it an identifier. So let's say function, or let's say simple function is equal to, and here we can specify whatever valid type there is. So we could use a string. So now this is an alias for string. So instead of using this native type that TypeScript already gives us, we can replace it with simple function. And we get the exact same result. But you wouldn't do this. It wouldn't make any sense. If this exists already, why would you use a type alias? Now, type aliases are used for your custom types. Types that aren't provided to you by TypeScript. Because your types are custom. It's unfeasible for TypeScript to give you types for every single function that could exist. So we can change this to be a function that returns, so remember, this indicates what the function is returning, and we can say void. Now here, we can say, okay, this is of type simple function. If we hover over it, we can tell what the type is exactly, and then we can type out a function, and it works. Now, something important when it comes to type aliases, and that is the identifier of type aliases should be Pascal case. Is it a hard rule that exists in TypeScript? No. It is all about convention. So it's very important that you follow these conventions so that your code is legible. So in this case, use Pascal case, and for variables, stick to camel case. So we can improve the clarity of this code by, first of all, getting rid of this, And let's start typing out each one. So which depends on which. The regular function depends on whatever this function's type is. And the same applies for this one. So we can type out this third function first. So type third function is equal to a function that returns void. So now we can change this type annotation right here for the third function. So now it's clearer because, well, we know that it returns this, so a third function. And then we can type the second function. So type second function is equal to a function that returns what? Well, our third function. And we can change this type annotation to use second function. And finally, for the first one, so first function is equal to a function that returns the second function. And then we can get rid of all of this type annotation and simply use first function. And as we can see, it's way more legible. We can immediately jump to this type annotation right here and see that, well, this is a function that returns second function. And this is a function that returns third function. And this is a function that returns void. So now that we understand how returning functions work and how type aliases work, I got a challenge for you in the next lecture. Let us now try and solve this challenge. First of all, write an arrow function named main that takes two arguments, two numbers a and b. Within the main function, return an anonymous function extracted to its own variable that uses both arguments a and b and returns their sum. Use the type aliases to define the type of the main function and the anonymous function. And lastly, call the main function and print the result to the console. Pause the video and give it a try. There are different ways to solve it, but I'll show you my solution. First of all, we define the type aliases. Main function is equal to a function that takes in two arguments and returns a number. And then we have the anonymous function that takes two numbers and returns a number. So in fact, you could omit the anonymous function and simply use these parameters, but for the sake of understanding how this works, I made it so the anonymous function is the exact same. So in fact, we can simplify this further and change it so it points to this type right here. And then we have const main function of type main function, these two parameters, and then we have the anonymous function. To a and b, and we add these two and return it right away. And then we can return the invocation of this anonymous function by passing these two parameters. And finally, we can log to the console 1 and 2, and we get 3. So obviously you could have gotten rid of this right here and deleted these lines and simply return a function without accepting anything and simply returns a plus b. But now this returns a function, right? So it needs to have to change this type annotation. Or the other one, if you want to keep it more concise, perhaps in a single line, you could change this to be an arrow function instead. And it simply returns a plus b. And again, well, this returns a function, so you need to invoke it twice, basically. And if we do this, well, we get 3. We are getting an error, well, because this type annotation is overriding the one that TypeScript could infer. So we could change this to simply a function that returns a number, as simple as that. All of these solutions are valid. And you could, of course, even simplify this further by removing these brackets and simply returning an arrow function, unnamed obviously, that returns the sum of these two numbers. Now that we have solved this challenge, we can proceed to the next lecture. Let us now take a look at IIFEs, which are immediately invoked function expressions. So suppose you have an anonymous function, so anon function, and we simply log to the console. But we wanted to execute this function right away. To do that, well, you could do anon function and invoke it right after. However, this is not very flexible because suppose you have a return here, so return hello world, and you wanted to assign whatever this function is executing and its return value to this variable right here. So instead of this holding the function, you want this to hold the return value of this function. So for that, well, you could have another variable. So const anon is equal to the invocation of anon function. However, there's an alternative to avoid this boilerplate per se, and that is using the immediately invoked function expressions, which are functions that when defined, you can invoke them right away. To create one, you simply wrap this up within parentheses. So now JavaScript considers this to be an expression itself, not a statement of when you're creating the function. And now, since this is an expression of a function, you can invoke it right away. And if we do this and delete this line, and let's change this name, now as we can see, anon holds a string instead of the function itself. So once it reaches this line, it is going to invoke this function, return this value, and now this variable holds this value. And they can be created anywhere. You can copy this and paste it without particularly assigning it to a variable, and it is still going to work. However, what if we skip this semicolon? If I delete this file and then Ctrl S to save it, they are now bound together. So since this is an expression, JavaScript doesn't know where exactly it ends. So this is why semicolons are very, very important. So in this case, you need to add it manually. And as you can see, the error goes away. Now, since we're using immediately invoked function expressions, that means we can only use this syntax with anonymous functions. And in fact, arrow functions are anonymous because an anonymous function is simply a function that has no name. So we can change this to be an arrow function instead. So get rid of this keyword and then use the flat arrow. And we achieved the exact same result. And since we're using functions, we can type these functions. So we can specify explicitly that we're returning a string, same as this one. And you can even pass parameters to it, though it doesn't make much sense. For example, you could receive two strings, so str and str2. And then you could return the concatenation of these two and str2. And then it says expected two arguments, and to pass them, well, since we're invoking it here, we can pass the parameters here. So hello and world. And if we log to the console anon, we get hello world to the console. And we can obviously use type aliases. So type anon result is equal to a string, and then use it here. Now let's take a look at how this compiles to JavaScript. If I open up the terminal, type npx_tsc to compile to JavaScript, and open the JavaScript file, we can see that, well, of course, this is going to disappear. All of this is removed once it is compiled to JavaScript. Now immediately function expressions exist in JavaScript, obviously, so this is why we get the exact same result. But we lose all type annotations, as we have seen before. So now that we understand how IIFEs work, we can move on to the next lecture. Let us now take a look at callback functions. A callback function is a function passed into another function as an argument, which is then invoked inside the outer function to complete some kind of routine or action. So for instance, suppose you have a function, operation, takes into numbers, and then takes in a function, so a callback. And for this, let us extract this to a type alias. So callback function is equal to a function that takes into numbers and returns a number. And then you can assign this type, and this will return a boolean. Perhaps this could be isValid. And then you can invoke the callback. So if callback, you pass in a and b, is greater than, say, an arbitrary number, so 10, then we could return true. Otherwise, we could return false. Now remember, this can be simplified. If this itself is returning a boolean, then this is redundant. So we can get rid of this and simply return callback is greater than 10. And now we know this callback returns a number, and that is the power of TypeScript. If you were to replicate this in JavaScript, there's no way for you to know what you're expecting exactly from this callback, and it would be really hard to read. You could perhaps know the comparator, and so you say, okay, this is an arithmetic comparison, but it is still not clear. So this is why TypeScript is an extremely powerful language. And now that we have specified a callback, we can pass in whatever function we want with whatever logic we want, as long as it has this signature. So we could test it out. So is valid, we pass in perhaps 20 and 40, and then a function which takes a and b, and then here we could return a plus b. And if we do this, we're using the power of anonymous functions. Since this is a regular function that requires you to specify an identifier, anonymous functions are incredibly powerful for callbacks, as you don't have to extract it into its own function. So from the outset, you may have created a function, so add, then a type number, b type number, and then this returns a number, return a plus b, and pass it as such, so add. However, you're decoupling the logic. You're separating this function into its own definition. So now not only do you have to be wary of these two parameters that you're passing in, you will also have to jump to the definition of this function to understand what it is doing exactly, rather than leaving it as we had before and using the power of callback functions. Now these are contained examples showcasing you the fundamentals of callback functions. You may not have found a use case for this. However, in the world of JavaScript and its whole ecosystem of libraries, callbacks are arguably one of the most important aspects of JavaScript, and you will be using them for everything. Let us dive now into objects. So what are objects? They are entities of key-value pairs. And they are in fact another data type. Just as we have with strings, numbers, booleans, and even functions, objects have their own place in data types. So let's look at a practical example. Suppose you wanted to store the information of a particular user. This user could have an email, could have a username, could have an age, and a function that when invoking this function, it logs to the console all of the data pertaining to that particular user. If I told you to do that, you'd create 4 separate variables. So perhaps const user1 name could be John, then you have user1 age could be 20, then email user1 email is equal to john@email.com. But the problem is, since we're not dealing with a single entity that contains all of these values, it is taking a lot of space. So we have to always make sure to create individual and unique identifiers. So if you had more than one single user, perhaps a second one, then const user2 name, and so on and so forth. And really this is unfeasible and extremely tedious. So this is why objects were created. So you could contain all of this information within a single entity. So let's take a look. To create an object, you have to use curly braces. So const user is equal to curly braces, like if it were a block of code. And inside here, you can specify the key value pairs. So this user has a name, then we use colon, and then we specify a value. So John. Then we have the age. So we have 20, and notice how we're separating them with commas instead of semicolons. And finally, the email. Now the reason we're using commas is so that we can specify the multiple key value pairs, same as with function arguments. And remember, a semicolon denotes the end of a statement. In our case, we're just defining user. Once we want to conclude that this user has been created for this line, to put it like that, we would use semicolons at the end of this bracket right here. And now, if we log to the console user, we can see all of the information pertaining to this particular user. And one of the huge benefits of this is, well, first of all, you have a single entity. You don't need to create multiple variables. And the second benefit is you do not need to come up with unique identifiers, only for the entity, or in other words, for the object. So now you can create another user. So const user2 is equal to an object, and you can repeat this one right here because this is scoped uniquely to this object. So now we can say Melissa, age 25, and then the email. And I forgot the colon. Now if I hit Ctrl S, you may have noticed that it adds this trailing comma, and this is defined in your previous configuration. I prefer to leave a trailing comma, so if you ever need to add a new property, you can just come here, hit enter, and start typing right away, without the need of typing the comma and then hitting enter. But now let's take a closer look at these key value pairs. These are known as properties. So this is a property. A property encompasses the key value pair. So whenever someone says add a name property, they refer to this. And you can specify the key, which is the identifier, and then its corresponding value. But let's try and see what if we were to duplicate this one right here. So perhaps after email, you add another name, ASD, and it says an object literal cannot have multiple properties with the same name. And if we take a look at what was printed, we have name ASD. And this is because if you repeat a key that has already been specified before, it is going to override that key and take this value instead. So this is still valid. This error comes from the TypeScript service. But in the end, as we can see from what was logged to the console, this is completely valid JavaScript. Having said this, we can get rid of this extra property. But now how do we add functions? Well, for that, remember, you can use anonymous functions, including arrow functions. So if you wanted to print something, so maybe print, you could use colon, then either function with the syntax right here, or with arrow functions. So parentheses, flat arrow, and then the brackets. And inside of here, you can print something, user John. And if I save this file and take a look at what was printed, we can see the function right here. But how can we invoke this function? And how can we access these properties? With variables, we can just reference them by their name, right? Well, for that, you have to use dot notation. So if you wanted to get only the name, which we know is of type string, as we can see here, we would have to use user dot, and then Visual Studio Code is going to autocomplete all of these for us. And we can just select the name. And as we can see, it just printed to the console John. And the same applies for a function. So we can simply reference function. Now we're just printing the function. And to invoke it, just pass in parentheses. And as we can see, it logged user John. But there's another way to access properties aside from the dot notation, and that is using bracket notation. So instead of user.name, you simply use brackets, and then it says an element access expression should take an argument. So you pass in a string, and then, well, you can do the exact same. So we get print, and then we can invoke it as such. But why would we use this notation right here? The only reason to use this notation is if the property's key name includes a character that you cannot use to reference. So something that is important to take into account is that keys are strings ultimately. So you can literally name your keys in an object however you want. But if you try it out, perhaps you say user me, this is not going to work. But if we change this to be a string and then we use colon, and then you say hello, this is valid. And now this is a property that if we print out user, exists in this particular entity. And if we try to access it with dot notation, user me, VSCode will automatically change this to use the bracket notation, since this is not a valid character to use. And one last thing, let's look at the behavior of functions. So there's a shorthand way of writing this function. So instead of using colon, then the flat arrow, or even the function keyword, you can just get rid of the colon, get rid of this flat arrow, and just leave it as such. And this is going to be a function that we can still invoke. So user.print. But let's say we wanted to access these properties within the function. I mean, if we can access these identifiers in the global scope, because ultimately this is where they were defined, shouldn't we be able to do the same within a function? Since this in a way pertains to this context. I mean, it is defined within the object in the end, right? And the answer is not quite. If we try to access, say, name within or age within this function, so print age, we get an error. Age is not defined. So how can we access age? Well, as we have learned, the only way to access these properties is via the dot notation. So via this identifier, we get access to these properties. So perhaps user.age. Now this works, obviously, but the problem with this approach is that you need to know the identifier. Wouldn't it be nice for there to be a way to not having to specify this identifier? Suppose you wanted to create another function and assign it to different objects, and this object has the user2identifier, this one the user, so you have to account for all of these possible identifiers, like to say function, print, and then you have all of this logic, but then how can you reference this if this function were to be within an object? For that, we can use that this keyword, and the this keyword takes the context. So in our case, this function is within the context of this entity. So we can write this.age, and this refers to the object itself. So if we were to get rid of age, as we can see, we get the exact same result as if we were to just print the user. However, when we're talking about taking the context, this only applies for normal functions. If you were to use an arrow function, unfortunately, the arrow function will not take the context of the current object, but rather take the context of the global object. So this, in essence, all of these where we define these variables is an object in a way. So if we were to change this to be an arrow function instead, as we can see, it says the containing arrow function captures the global value of this. Hence we get an error because this is obviously not something that we want to use. So this is why it's better to stick to the other type of function, just to make sure that we can access this. So now that we have learned about the basics of objects, we can move on to the next lecture. Let us now take a look at how to add, modify, and remove properties from an object. To add a new property, well, you can come here and specify the key value pair. But let's say you wanted to add a property if a condition is true, perhaps if the age is greater than or equal to 18. To do that, well, you could use the dot notation. So if user.age is greater than or equal to 18, then user.phone number is equal to, and I'll delete this property right here. And if we log the user, we can see that we get the phone number property. Now TypeScript throws an error and says property phone numbers does not exist on this type. And the reason is because, well, once you create an object, TypeScript will create the type from the properties that you specified from its initialization. So if we hover over user, we can see that this is the type of this object. It only contains a name, an age, and an email. There is no phone number to be seen. Now, if you were to do this in JavaScript, this would work just fine. And in fact, we can see the result, because since TypeScript is compiled to JavaScript, even though TypeScript might throw an error, it will still run just fine. So how can we add this new property? Well, you need to create and assign to this user an optional property. And that makes sense because only if the user's age is greater than or equal to 18, then we want to add this property. So we can't say for sure that phone number will exist for every single user. But how can we achieve that? Well, let's start by typing out objects. So we can use the type alias, type, user, remember Pascal case, and then we use the bracket notation to specify that this is going to be an object. Now, right now, this object is empty, but now we can say this user will contain a name of type string, then age of type number, and email of type string. And then we can come here and assign this type to this user. And by doing this, we now get autocomplete. So let's say we don't have the email specified. We get an error saying property email is missing in this type. So if I come here and hit Control Space, Visual Studio Code will show all of the properties that I can add to this particular object. In this case, the first one is email, and we can see here property email of type string. So if I click on it, it is going to add the key automatically, and then I can specify whatever I want. So let's go back to this example. So how can we add a new property? Well, I told you that it should be optional. In other words, it cannot be required because not all users will have phone number. So we can come here and type phone number, and instead of making it a hard rule that it must have a string, we can add the question mark right here, right before the colon. And by doing this, now user has the phone number property that can either be a string or undefined. Since you didn't know about this feature, you may have been inclined to use a union, so string or undefined. But if you do this, then you have to specify phone number as undefined. And since we're already explicitly defining that it is going to be undefined, then a better value would be null. So it could be string or null. But it's better to use this optional syntax, and then we can get rid of this union and get rid of this property. And now if we try to access the user's phone number, user.phoneNumber, it has a question mark because it can either be a string or undefined. So if you want to access the user.phoneNumber, you need to validate that it exists. So if user.phoneNumber is different from undefined, then we can log to the console user.phoneNumber. What about removing properties from an object? Well, for that, similar to the type of, so we have type of, we can use the delete keyword. So we can do delete user.phoneNumber. What this is going to do is just get rid of this property. Now, super important, you can only use the delete keyword if the property is optional. Let's try deleting name. Delete user.name. We get an error and says the operand of a delete operator must be optional. So we need to change this to be optional, and it makes sense. Now you might find this tedious, but it's designed to be fully type safe. And finally, what about modifying a property? For that, well, you can simply come here and do const age is equal to 15. And if I log the user before and after, so after age 15 and before user.age, it's going to be 24. And finally, well, when it comes to assigning a data type, it is not required to create a type alias. You can actually, well, just get rid of this type alias and do it manually here. So I'll just copy this type and paste it here. And now we just achieved the same. However, type aliases are great because you can name them whatever you want. You do not have all of this type annotation within the declaration of this variable, which hurts legibility, and you can also reuse type aliases. So if you had more than one user, so const user2, you wouldn't need to specify the whole data type once again, just point to user. And here it is telling me that it is missing the following properties, so age and email. And if I hit Control Space, we can see that name is optional and phone number is optional. So start getting used to objects because you will be using them for absolutely everything. Let us now move on to the next lecture. So now I have a challenge for you. Create an object called person with the following properties: name of type string, age of type number, email of type string, and then write a function called updatePersonAge that takes an object of type person as an argument and a new age of type number. The function should update the age property of the object with the new age and return the updated object. Give it a try. First of all, we must define the type alias. So type person, name of type string, age of type number, and email of type string. And then we can create our person object. So of type person, and the name John, age 25, and email john@gmail.com. And then we can create the function update person age, which takes in a person, the new age of type number, and returns a person. And then we can change person.age. Let's log person to see if it works, and then return the new person. And we can invoke this function update person age. We pass in the person and then the age, so 18. Now I noticed I'm not assigning this new value, so equals to new age. And as we can see, the age is 18. But let's take a look at the person object, the one we passed in. If I log it to the console, which is not the one that is being returned from this function, in fact, I'm not even assigning it to another variable, we can see that the age is now 18. And how come this happened? We learned that whenever we pass in a value as an argument to a function, it will create and allocate a new memory space in the stack. So if we ever perform any type of modification directly, it is only going to affect that of the context of the function and not the original value. However, if you recall correctly, we have the heap, which I didn't show in its entirety. So instead of storing in the stack, so person and then the object right here, it must save a reference or an address to its place in the heap. And the heap is used to store data that can grow and shrink dynamically. A number is static. If you initialize a variable with the number 20, then that's all there is to that variable. If you later modify it, it can simply add the new value to the stack, and that's about it. So whenever we pass in a number to a function, then it is going to add a new entry in the stack. But that would be unfeasible and very inefficient to deal with dynamic data that can grow and shrink in the stack. So that's why the heap exists. So instead of, in this case, whenever we invoke update person age, it will not create a new person object and add it to the stack. It is simply going to pass the address in memory to the heap. So that's why if we modify the person.age, it is going to modify the original person. But why does it work like this? That's because suppose an object could have 1,000,000 different properties, or even 2,000,000, and every time you invoked a function and passed in that object, it created a new entry of 2,000,000 properties in the stack. So you could potentially have 20 or 30 objects, each of 2,000,000 properties. That would make your program extremely slow. So that's why instead of creating a new entry, it is simply going to reference to the heap and use the already created data. And this is obviously going to be a much more efficient process. So that's why we must be careful to not modify directly a property of an object, unless the function is intended to do that. What if you're using a third-party library? You expected it to return the updated object rather than modifying your object. That would be a really bad developer experience. So that's why we can clone objects, which I'll show you later on how to do that, to avoid this type of behavior. Now, is it the most efficient way? Not at all, but JavaScript is a very high-level language, so it's fine for what it is. So now that we understand the heap, let's move on to the second challenge. Create an object called product with the following properties. So name, price, and quantity. Write a function called validate product that takes an object of type product as an argument and checks if all of the properties have valid values. For example, the name should not be an empty string, price should be a positive number, and quantity should be a whole number greater than or equal to 0. Return true if the product is valid and false otherwise. Pause the video and give it a try. The solution is pretty straightforward. We can create the product, name of type string, price, number, and then quantity. Then we can create a product of type product, and then the name, let's leave it empty. Price, let's say it's a negative number, and the quantity, let's say it's going to be 3.4. Now we can create our function, validate product, which takes in a product, and returns a boolean. Now here, the first condition, it must be different from an empty string. So return name different from empty string. Then we need to check that the price is not negative. So and product.price is greater than 0. And then we need to check that the quantity is a whole number, so an integer, and that the quantity is greater than 0. For that, if you researched online, there's a function in the number object. So number dot is integer, and we can pass in the product.quantity. And then we must check that the product.quantity is greater than 0. And if I save this file and log to the console, validate product, and we pass in this product, we can see that it outputs false. And that is, well, because the name is invalid. So let's change it. Still false because the price is negative. So 2, still false. And what about a whole quantity? Now this is true. Now let's try empty string, invalid, price, negative, invalid, and quantity. If it's -1, then it is invalid. Having solved these challenges, we can move on to the next lecture. Let us now take a look at how to destructure objects. So suppose you have an object with name, last name, string, so this is actually the first name, and then we have the age, which is a number, and we can assign this to a variable, so user of type user, first name, John, last name, though, and then age. And let's say we want to access one of those properties, but for some reason we do not want to use the dot notation, like this. One way to achieve that is using the destructuring assignment. So you can actually bind this to a variable. So you type const, then the brackets, and then equals the object you want to destructure. And by doing this, you can extract each property individually. So suppose you only want the first name. And now this is bound to a constant. That means you cannot create another constant with the exact same name. And if we log this to the console, so log first name, we get John. But now let's imagine we have another user. So const second user of type user, first name, second, then last name, user, and then the age. And we wanted to destructure it equally. So const first name is equal to second user. Now we get an error saying cannot redeclare block scoped variable first name. And that makes sense. So how can we go around this? Well, for that, you can use the colon and then specify a custom identifier. So you could say second user's first name. And now if I log second user's first name, we get second in the console. And this is powerful because suppose you have nested objects. So you have another one, cart, we have the item, which is going to be a string, and the price, number, and quantity, which is a number. And the user has a single cart item. So we can write cart item of type cart item. And then we need to add this here. So cart item needs item, something, then the price, and then the quantity. And I'll remove this for simplicity. And now we can access the cart item solely. So we can write cart item instead and print that to the console. So now we have this object. Obviously, you can achieve the same by just doing user.cartItem. But what about destructuring nested properties? So we know this is an object. How can we achieve the same but with cart item? You might be inclined to do const is equal to cart item. And then you get the item, price, and quantity. However, there's a simpler way, and that is simply using colon, and instead of renaming the property, we use bracket notation once again. And inside these curly braces, we can still keep destructuring this object. So we can access price, item, and whatnot. And by doing this, well, we cannot have access to cart item anymore. As we can see, cannot find because it is not defined. And that makes sense because, well, we're accessing these two. So now we can access item, comma, price. So remember, when you use column followed by curly braces, you're destructuring the object. Otherwise, you're renaming the object. And how can we use this with function arguments? Well, let's try it out. Function print cart item. And suppose we take in a user. So of type user, this is going to be void. And instead of dealing with the whole user, so log user.cart item, and you know you will only be using the cart item, then you can simply take user and destructure it as such, and then control space, and you can grab cart item. And now, if we invoke this function and we pass in the user, as you can see, we log to the console this object. What if we remove the type annotation? Well, we're going to get an error because it says cart item implicitly has an any type. And that makes sense. So let's leave it with the user type. However, destructuring isn't extremely useful by itself, at least the features we have delved into so far. Personally, I prefer just to have the whole object like such, and then I can just grab the cart item by using that notation. And there are a lot of people that like using as many features as possible, so they will destructure every single object in existence. Now, I'm not a fan of that, because suppose you now need the first name and the last name. So instead of just being able to do user.cartItem, user.firstname, and so on and so forth, you need to come back here, add a comma, then add the other properties, and then you can reference them here. So that seems unnecessary. However, one of the benefits of destructuring is that you can actually grab only, let's say, the first name, last name, and the age, and omit the cart item. So let's say this function only accepts the cart item. So you can come here, destructure the cart item, and then you can pass in the cart item. And obviously you have to get rid of all of this cart item. And you want to get the first name, last name, and age separately. For that, you can use the rest operator. So comma, 3 dots, and then you can specify whatever identifier you want. In this case, since it's the user's general information, we could type it as such, general info. And if I hover over general info, it's now an object with only these 3 properties. So remember, this is the structuring assignment, and this is the rest operator. And in fact, if there are even more nested objects, you can grab another one. So let's do anything. Then this contains A, B, and then D, which is a string. Then we can come back here, add all of these properties. So A is an object, B is an object, and D is a string. And then we can come here, and this pertains to cart item. So destructure cart item, then grab anything, then destructure anything, then destructure A, and finally destructure B to grab D. So now you can log to the console D. And as we can see, we get an empty string back. So now we can move on to the next lecture. Let us now take a look at the optional chaining and Nullish coalescing operator. So suppose you have a session. So this is for your front-end web application. And the session has a status. So whether the user is authenticated or not. So status, and this will be a union. So authenticated or unauthenticated. So it must be one of these 2 literals. And in the case that it is authenticated, then we get access to the property user. So let's type here, type user, and this user has an identifier, which is unique. Then it has a name, so string, and an image URL. So this is of type string as well. And then it may have a role, though not all users have a role. For example, if it is a base user, then it doesn't have a role. However, the user could be an administrator or could be a moderator. For that, the role is optional, and this role is an object with an identifier as well, and then a boolean has all permissions for this web application. And here, well, the user is optional itself, depending on this status right here. So of type user. And now we can create our object. So const session of type session is equal to an object. Then the status could be authenticated. So we get autocomplete. And then we can define the user. So in this case, it is not undefined. And it has an ID. Let's keep it simple. Maybe ID1. Then the image URL, HTTPS something. And then the name itself, so John. And let's say we wanted to know if the user has all permissions or not. So basically, we have to traverse this object. We have to check for user first, then check for the role, and then check this property. And if this is undefined, so if the role is undefined, so the user doesn't have all permissions anyway. So you could try doing the following. So session dot user dot, and then you try accessing the role and then has all permissions. However, this is not going to work because session.user is possibly undefined, so you cannot access a property of something that could be undefined. In our case, we know this isn't undefined. However, we could imagine that this session does not have a user, so it is unauthenticated. But you still need to, well, validate has all permissions. One approach would be to check each property individually. So, if you wanted to know if the user has permissions, so you would set this to false, then check if session.user is different from undefined. Then we can check for the role. If session.user, so now we know this exists, dot role is different from undefined, and then we can check as permissions is equal to session.user.role.has all permissions. And as we can see, well, this works. So it is set to false initially, like some sort of fallback. And in the case that the role is different from undefined, then we can check for sure if the user has all permissions or not. But again, this is tedious and it is not legible. What if you had way more nested objects? It would soon become a headache. And let's not forget about the use of let. You would leave the reader wondering when it is going to change in the future. So this is overall bad practice. Fortunately, they introduced something called optional chaining, where you can use either bracket notation or dot notation to access properties where the parent could be undefined. In the case that the parent is undefined, you simply get undefined back. In the case the parent is not undefined, then you get the value you're looking for. So let's say, I'll comment all of this out. Const has permissions. Then we can come here, we note that the user could be undefined, so we use a question mark. Then we get session.user.role is possibly undefined, so we do the same. And now we just simplified all of this logic down to a single line, and this is way more readable. But if we take a look at has permissions, it is either a boolean or undefined, and that makes sense because remember, optional chaining will return to you either undefined or the value you're looking for. So if the user is undefined, you simply get undefined. If the role is undefined, you simply get undefined. In the case that this is not undefined, so we can access has all permissions, you simply get the boolean of this property. But now another problem arises. Okay, you need to have a fallback. This needs to be false if this were to be undefined. So now you have to resort to using ternary operators. So now you need to check, okay, is this different from undefined? If it is, then session.user.role.has all permissions, otherwise default to false. Now fortunately they introduced another one, which is the Nullish Coalescing operator, where if the left-hand side of the operator is either undefined or null, then it will take the right-hand value. So in this case, we can get rid of all of this and simply use 2 question marks and then specify false. So what this is going to do, again, is going to check, is this all of this undefined or null? If it is undefined or null, then take this value instead. So now if I hover over has permissions, we can see that it is of type Boolean. So let's take a look. If I log has permissions, we get false. If I remove this Nullish Coalescing operator, we get undefined. But now let's manually do it and try different cases. So undefined, then Nullish Coalescing operator, what about null? So left hand side is undefined, so take the right hand side. But since this operator is also looking out for null, then if we use it again and pass in a string, then we get empty string. And actually there are people who do not use the Nullish Coalescing operator because they do not know about its function and how useful it is. So people have resorted to using Boolean comparators. So instead of the Nullish Coalescing operator, they use OR. And if you recall from Truthy and Falsy values, since undefined is a falsy value, then it will take the right hand side, so false. But this is terrible. Why? Because, well, let's try it out. Undefined or null? We get null. What about undefined or null or an empty string? Now we get the empty string, so this makes sense. But what if this was maybe the name of the user, and the name of the user could be an empty string? So instead of undefined, we have an empty string. And if I get rid of this, or null, we get null, because empty strings are a falsy value, something that wouldn't happen with the Nullish Coalescing operator. As we can see, we get empty string. So whenever you see this practice, go ahead with confidence and change it to the Nullish Coalescing operator. So now that we understand the value of these two and how they work, we can move on to the next lecture. Let us now take a look at the non-null assertion operator. So let's say we're completely sure that user and role do exist, so these two cannot be null or undefined. However, if we recall and get rid of the optional chaining, then we get an error. And this error is a runtime error, telling us cannot read properties of undefined. But what if we had a user? But even though the type is telling us that the user can be undefined, we know for a fact it is not undefined. So what can we do in this case? Well, for this we can use the non-null assertion operator. So instead of question marks, you use an exclamation sign. And this is telling TypeScript that the user property does exist and that it cannot be undefined or null. And we can do the same with the role. However, this asserts to the TypeScript compiler that the value of the expression is not null or undefined. So it is essentially telling the compiler to trust that the value will be present in the runtime, even if the type system suggests it could be nullable or optional in this case. However, using this operator should be done with caution, as it bypasses TypeScript's type checking. So in this case, this user object does not contain the role property. And as we can see, we get a runtime error, telling us cannot read properties of undefined. So you should only use this operator when you're absolutely sure that this property cannot be null or undefined. However, this is bad practice and you should really only use it in extremely specific cases. It's best to always use optional chaining instead, and then use it along with Nullish Coalescing operator to provide a fallback in case anything goes wrong. So now let's take a look at how to make an object read-only. So that means that we cannot add, remove, or modify the properties of an object. The most common approach that is also available in JavaScript is by using the object.freeze function. And similarly to the console object, object is also a global object that we can access from anywhere. And if we look at the signature of freeze, it receives f, which is object on which to lock the attributes, and returns a read-only object. So let's try it out. Let's pass in session. Now if I do this and hover over freeze again, we can see that we're passing O, which is the object of type session, and it is returning to us a read-only session. So again, we cannot modify existing property attributes and values. So let's try it out. Let's come here and assign this read-only user, or actually read-only session. And if we try reassigning status to something else, we get an error saying cannot assign to status because it is a read-only property. However, the problem of this function is that it doesn't affect nested objects. So that means that if we try reassigning user.id, we do not get an error. However, well, we have defined that user can be optional. So what if we use the optional chaining here? If we do this, we get an error. The left-hand side of an assignment expression may not be an optional property access. So now you learn that we cannot use the optional chaining with an undefined property when trying to assign it to a new value. So for this example, let us simply get rid of this optional. And as we can see, it didn't throw a single error. And if I log to the console read-only session, we can see that it successfully modified ID. But what if we try modifying user to a string instead? As we can see, it doesn't print anything because we get a runtime error. But wouldn't it be nice to create a read-only function within its own initialization? Well, for that, you can simply use object.assign and pass in this object. And you just achieved basically the same, but within one single declaration. However, wouldn't it be nicer to be able to specify individual read-only properties? And you can actually do that. So first of all, let's get rid of this and come up here to the type definitions, and we can actually add read-only to each property individually. So we can type that ID must be read-only, name must be read-only, image URL. So now if we try to reassign, so session.user.id is something different, we get an error saying cannot assign to ID because it is a read-only property. And if we log to the console session, as we can see, it did modify the ID. Why did this happen if we clearly set the ID to be read-only? And that is because, well, we just enforced this in the type level. Once we compile to JavaScript, there's nothing to enforce this from happening. But again, as long as you're using TypeScript correctly and that you're checking for errors, there's no need to enforce this at the runtime level. Thank you for watching this preview of my course. To access the full content, including comprehensive lectures, exercises, and resources, please check out the referral link in the description. I look forward to seeing you inside and helping you achieve your goals. Thank you for watching and happy learning.